there are one speaker who has several special reasons. So I think he the Vladimir he represent. Okay, yeah. So we will have 3 speakers for this session 1. Okay. The first speaker is Nikolai Petrovich Mesnikov. Okay, who is the leading engineering from the Ammosov Northeastern Federal University, and also from the Institute of Physical Problem, from the Russia Academy of Sciences. He will give a talk on the about the topic for study of which to improve the energy efficiency of solar power plants of micro small capacity in the condition of the north. Okay, so let's welcome Nikolai Perosov-Masnov give his talk. Okay, yeah. Is he here? Nikolai here? Dr. Nikolai here?
I'm sorry.
Yeah.
Maybe your first speaker is Dunichkin Ilya Vladimirovich. Cause I have new program. They give me for section 2, and I see your first speaker is from Moscow State Building University with talk renovation of offshore oil and gas structures of the Russian Arctic to increase biodiversity of the water area and generate energy. Is he here?
Okay, yeah, here.
Do we have administration here for help us? Dunichkin Ilya Vladimirovich. Okay, and what is the next by your program? What is the next talker in your section?
I think is let me see. Qiu Tian from Beijing University of Chemical Technology. Yeah, is Qiu Tian here? Okay. Yeah, maybe. Yeah, they have their time.
Yeah, maybe have some technical issues with connection or something. Just wait.
Yeah, Qiu Tian. Yeah, so your Yakutaki time zone is a little bit later, right? Earlier, before the Beijing time, right?
Yeah, right. 1 hour difference.
Yeah, 1 hour. Yeah. Yeah, usually, in most time zone in Russia, we think it will be behind our Beijing time.
Yeah.
Okay.
I contact with administration and say them that speakers still don't connect. Maybe Moscow people, they skip time because they don't understand difference between Yakutsk and Moscow or something.
Yeah,
And
behind. Yeah. Or earlier, 1 hour, 1 hour time difference. Okay. Okay, maybe I will ask some colleague from the Beijing University of Chemical Technology.
okay, Xu-Tian, do you hear? Can you listen us?
He didn't respond. Okay, yeah, I will ask someone. But the third speaker and will give the talk first. Me. Vladimir.
Vladimir Viktorovich Filatov. This is your third speaker today.
Okay. Vladimir will first, and then the Ilya will the second one. Totally, there will be 3 speakers.
Yeah.
The organizers are saying that the speakers have not connected. Oh, you have Vladimir Filatov online.
Maybe if nobody don't have mind, Filatov Vladimir joined it.
Okay.
And I don't know, maybe you wish to change order of talkers. I don't know.
Okay, Sure. Any speaker here can give the talk.
Vladimir Viktorovich Filatov, do you ready to present your talk today?
Good morning, dear colleagues. I need 15 minutes, please, to prepare, okay?
Yeah. Yeah,
okay.
sure, please. Yeah. Okay, good. Yeah.
Okay, I'm ready.
Yeah, good. Yeah, please.
So, can I start?
Yeah, sure. Please.
Okay, dear colleagues, good day to you. My name is Vladimir Filatov. I am a director of Automobile and Road Engineering Center based on Moscow Automobile and Road Construction State Technical University, Moscow. So the theme of my presentation is modern digital engineering solutions for the development of road and transport infrastructure in the Arctic region. The purpose of our engineering center is to form engineering and educational competencies at University MADI, allowing to carry out research and development work aimed at solving urgent problems in the industry of transport vehicles for various purposes, including Arctic region, as well as to train qualified engineering personnel for domestic industry enterprises with an emphasis on advanced methods, development and production of products. Engineering Center AREC creation objectives, implementation of commercial, educational, and engineering services involving project teams consisting of students, graduate students, young scientists, and engineers under the supervision of experienced project managers from among the staff of MADI University and partner design organizations. Implementation of consulting services to support the production of high-tech products. The introduction of automation of design, production, and project management processes through PLM, product lifecycle management technologies, which reduce the time spent on research and development and improve the quality of the result, comparing to the automation of engineering jobs through computer-aided design systems without the introduction of product lifecycle management systems. Organization of conditions for conducting initiative research and development work by project teams, including work on startup projects. This is students projects, startup projects. Continuous work to create new and improve the quality of existing educational programs implemented by AREC employees due to the use of advanced digital solutions for performing engineering work. The continuity of the educational, theoretical, and engineering practical components in the work of AREC and the consistent developments of competencies in the implementation of commercial engineering projects. Strengthening the status of MADI University as an industry institute dealing with applied problems of the transport machinery industry and taking an active part in the process of forming Russia's technological sovereignty. Our main customers and partners. There are plenty of government departments, companies, and private companies also. Our points of cooperation are digital development and engineering commissioned by industry enterprises, integrated intelligent design of complex and unique transport systems, which is also very actual for northern regions, as you know. Development and implementation of strategies for inclusion in federal and regional development programs, development of the educational block of the center in relation to ongoing engineering projects, outsourcing of scientific and research functions, specialization in electric and unmanned vehicles. Our engineering services. There are some quite actual engineering tasks for our center that are development of products or their components of varying complexity, reverse engineering, which is also actual now for Russia's industry, because as you know, many foreign companies left from the domestic market of Russia, also machinery, heavy industry, and in many other industries where foreign companies were represented. Development of design, operational, and other technical documentation. Restoration and digitalization of design, operational, and other technical documentation. Statement, implementation, and verification of the results of numerical experiment. 3D scanning and modeling of full-scale product samples. Industrial design, project support, and engineering consulting. Our engineering center participates at all stages of the life cycle of the product development, as you can see. So we start from participation in the development and analysis of initial data and take part in every part of life cycle of product development up to support of installation series for production of the product. Our educational services are include implementation of educational services under the program application of product lifecycle management systems for product lifecycle management, digital design and technological preparation of production, application of system engineering methods in the process of design systems in modern machine building industries. And also we cooperate with private company Top Systems. They specialize on CAD systems, CAE, and CAM systems. And their digital product called T-Flex. T-Flex software includes structural design, engineering analysis, data management, and technological preparation and production models. As you can see on the pictures, we have our own data server where we can produce digital modeling, structural design, engineering analysis to prepare the to analyze in virtuality the characteristic technical specifications and characteristics of the designed products. Also, we take part in project management and also based on PLM systems, as I said, product lifecycle management systems. So it also based on T-Flex software, T-Flex Docs utility that includes engineering process and design management, customized information system, integration with major MCAD systems, project structure management, managing company product range, corporate data and classifiers integration with ERP systems. As example, 1C system, also Russian software, mail and tasks, workflow management, project management, cost and resource planning, enterprise knowledge management, and archive, general office and desk workflow. Colleagues, thank you for your attention. I'm glad to answer the questions, if you have any. Thank you for your attention.
Okay, can I ask a question?
Yes.
Thank you. This is a really interesting topic because this connected with our region, Republic of Sakha-Yakutia, and is it some kind of technology that connect IoT technology and some road building or something? Do you have real implementation of your technology in real life?
We usually use the existing software to design and construct roads with maximum performance. So we also have some educational programs for the employees of real sector of economy for Russian companies, in which we are introduce these software products. And as you know, BIM technologies, the technologies that connected with creation the digital sample of the road, and you can optimize the characteristics of these roads to maximize performance and improve characteristics for of these roads that you construct. And our university has some chairs that have profile in design and construction of roads. So we are using the existing software products, but we have our own unique methods of applying of them in design.
So you, like I understand, you provide some technical and software solutions for
Yes, of course. Yes,
design roads. Yeah, but
yes. We also have some projects. I'm not sure in your region or not, but we have that experience to project and design roads with modern digital solutions and with modern technologies of construction.
Oh, okay, and your modeling and design of roads, it is based on what computational methods, maybe some finite element or
yes, computational methods. I can say, for example, we use software based on Autodesk complex. As you know, this is the foreign complex, not Russian product, but it's quite popular in this industry, you know. So we are using these models of Autodesk software to produce our projects that are connected with road design.
Oh, okay, thank you.
Okay, yeah. Maybe any other speaker here? Maybe you can, yeah, give the talk.
I see the second speaker connected, Xu-Tian.
Yeah, okay,
from
yeah,
Beijing.
great, yeah. Yeah. Hello, Qiutian. Are you ready to give your talk?
Yes, I'm ready.
Okay, good. Yeah. So please, yeah, take your time to give the talk. Okay, you have, I think, yeah, maybe 15 minutes. Okay, yeah.
Okay.
Yeah, good. Yeah. Go on, please go on.
Good afternoon, scholars and teachers. I'm the reporter of this conference. My name is Qiutian. The topic of my report is risk under pressure relief effect of a new type of explosion proof door with prior pressure relief structure. The research comment is as follows. As we all know, in the major coal mine explosion accidents at home and abroad, the explosion of the accident caused by the failure of the explosion proof door often occurs, mainly reflected as this follows. As we can see in the picture, the explosion proof door would be damaged. First, we establish the explosion proof door Weber and chamber model. The height of the Weber is 16 meters. The diameter of the Weber is 6 meters, and the width of the air chamber is 4.6 meters. In order to analyze the pressure relief effect, different types of explosion proof door with 0, 5, 10, and 15 tubes were modeled. In order to study the change of overpressure in Weber with different types of explosion proof doors, monitoring point 1, 2, 3, and 4 are set in the Weber. monitoring 1 is at the bottom of the webber, and monitoring point 4 is at the top of the webber. Next, from the opening height and speed of different types of explosion profiles, we can see that the more tubes will lead to the low opening height of the explosion profiles at the same moment. And from the opening speed, we can see that before 60 milliseconds, the more tubes of explosion profiles will lead to the greater opening speed. And from the average overpressure on different types of explosion profiles, we can see before 76 milliseconds, the overpressure acting on the explosion profile with 0 tubes is the largest, and the overpressure acting on the explosion profile with 15 tubes is the smallest. To further analyze the overpressure change on the explosion profile during the opening, the overpressure cloud diagram on the inside of the explosion profile at 5 milliseconds is extracted. With the increase of the number of tubes on the explosion profile, the maximum overpressure acting on the inside of the explosion profile keeps decreasing. The maximum overpressure on the inside of the explosion profile with 15 tubes is only 5.6 kilopascal. Next, we from the overpressure change in the webber to analyze the pressure relief effect of explosion profiles. As we can see from the picture, the overpressure at each monitoring point in the webber of explosion profile with 0 tubes shows a decreasing trend, as showing the black line, while the overpressure at each monitoring point of 5, 10, 15 tubes shows a trend of increasing first and then decreasing. Before 10 milliseconds, the more tubes on the different types of explosion profiles will lead to the low overpressure at each monitoring point in the webber. The maximum overpressure in the webber of different types of explosion profiles appears at the initial moment, as shown in the picture. At the initial moment, the overpressure acting on the webber of 15 tubes is the minimum. For different types of explosion profiles, the more tubes will lead to the more significant parent pressure relief effect. In order to further analyze the overpressure change in the webber of different types of explosion profiles, the overpressure cloud diagram in the webber at 5 milliseconds is extracted. At the 5 millisecond moment, the overall pressure in the web of different types of explosion products continue to decrease from the bottom to the top, and with the increase of the number of tubes, the overall pressure continues to decrease. Finally, the main purpose of this paper is to explore the pressure relief effect of the new explosion product with a different number of tubes. The main research conclusion as follows. The more tubes will lead to the low opening height of the explosion product at the same time. Meanwhile, the more shockwave acts on the explosion product. The overall pressure on the explosion product with 15 tubes is always lower than other tubes. The more tubes on the explosion product will lead to the better pressure relief effect. The overall pressure in the web decreases with the increase of the number of tubes before the explosion product is opened. The more tubes will lead to the better pressure relief effect. It's the end of my report. Thank you for your listening.
Okay, thank you. Yeah, it's a very interesting talk.
Oh, thank you.
Any questions? Okay, any questions?
Can I ask some question?
Yeah, sure, please.
Very interesting topic. Thank you again. And let me ask the question about is this investigated by computer modeling or real experiments?
Oh, okay.
Or you combine these two methods? Because I see some pictures like is computer modeled. Okay, do I need to repeat my question?
Yeah, sure. Maybe he didn't. Yeah.
Okay. Question. First of all, your pictures when you show results, some pictures they looks like your research was based on computer modeling, but on the other case, some results also I see you put some points and maybe you put some indicators over there, maybe some physics experiment, real experiment. So what was that? A real experiment or the computer-based modeling? And if only computer-based modeling, do you compare with some physics results? I think you can answer on Chinese because we have translators here and they can translate for us.
I set some monitoring point in the Weber, because I want to analyze the overpressure in the Weber, just some monitoring point in the Weber is to analyze the pressure relief effect. Is my answer. Thank you.
Okay, I see. So this is monitoring of explosion. Okay, thank you. Thank you again.
Okay.
Oh, thank you.
Yeah, good. Thank you. Yeah. Bye-bye. Okay, yeah. Any other speaker? Maybe the Ila Vladimirovich here is the first speaker here.
Yes, I'm here.
No. I mean the
listening.
scheduled first speaker. Yeah, you have give the talk. I know that, right? Yeah, but I know. I mean the first speaker. Yeah, in the schedule or in the agenda?
In the program, you mean? Yes.
Yeah. In the program agenda or in the program. Vladimir Dunichikin from Moscow State University of Civil Engineering. Maybe too early for him. He's in Moscow, so be very early in the morning, right?
Yes, actually, in Moscow there are 8 o'clock. You know. Yeah.
Yeah, I think yeah, should be 5 hours time difference.
Yeah, between Yakutsk and Moscow, 6 hours. Between Beijing, 5.
Oh, 6 hours. Wow. Okay.
Yes, I think many speakers didn't come that because of time difference. You know.
Yeah.
They didn't pay attention to
Pay
this.
attention. Yeah, they didn't pay attention to the time zone. Yeah. Yes. Okay. Okay, I think yeah should be yeah, our session 1 should be okay. Yeah, right. We can close the session 1 maybe. Yeah. Because
Okay.
according to the program book, yeah, should be yeah the first the session 1 should be closed on the yeah, you know, the 15th yeah, the 5 minutes to the 2 o'clock PM. Okay, yeah, so
Okay,
yeah,
thank you.
yeah, thank you everyone. Yeah, and then maybe we have yeah, oh no, yeah, we have a coffee break here. Okay, or wait for the and then wait for the session 2, right? Yeah, should be the
Yes.
the session 2 is in the different Zoom link.
No, I think we continue here.
Okay, yeah, but should be here. Yeah, then the doctor or the doctor is Alexander.
Alexander,
Yeah,
I'm here.
Alexander.
Yes.
Here.
Yeah, I'm here.
Okay.
Thank
Oh,
you.
you are here. Yeah. Sure, please. Yeah, it's your time to be the monitor. Yeah.
Yeah,
Okay.
I will start just right after coffee break. Just
Okay. Yeah.
uh,
Yeah, maybe 5 minutes, 5 more minutes or
for 5 more
yeah.
minutes. Yeah, 5 more
Yeah,
minutes,
5 more
and we will
minutes.
start.
Yeah, you can continue. Yeah, thank you.
Okay, thank you.
Really go on. Yeah.
So, hello everybody, dear participants of conference, dear guests, dear listeners. I want to start section 2 again. Big thanks for moderator of the section 1, Professor Shan. And let me introduce the section 2 is developing of the IT infrastructure, Russian and Chinese IT industry potential. So moderator today is Grigoriev Alexander Vissarionovich. It is me, Associate Professor of Institute of Mathematics and Informatics, Northeastern Federal University. And at the same time, first presenter. And my first talk is mathematical modeling and artificial intelligence of Arctic problems. So let me share screen with you. Okay. Can you see my screen?
Yes, we can.
Yes.
Oh, okay. What? Sorry. I want to start. Okay. So maybe it's okay like this. So my topic is the mathematical modeling and artificial intelligence of Arctic problems. And you know, there are big story between our two countries, and in participate we have some long collaborate story with the Chinese teams. And here this sorry. Okay, I need to choose demonstration. Maybe like this. Okay, I see. And here the story, some prehistory. There are some program, a big grant of Russian Federation that our team in Yakutsk won in 2017 with the professor from the Texas, United States, and he lead our team even today. And 2017, not only him share his experience in scientific work and also lead our team, but also he share his great contacts with the other research world laboratories, so we can connect with some leading laboratories in the world in our field. So on the basis of this, we connect with this Shantan University team. And this year, I want to describe that we joint grant, Russian Scientific Foundation and the Chinese Scientific Foundation cooperation grant. And this grant topic is novel computational methods for non-local multi-scale models and applications. And this technology is based on the, first of all, is some multi-scale models, but also here we include some technology, this connect mathematical modeling. Sorry, if Hang, you don't turn off your microphone. Can I do this for you? Okay. Sorry. Okay. I don't have administrator. Can you please turn off? Okay, thank you. So our basis is again multi-scale methods and multi-physics modeling, but also this is all computational fields. But right now we include also machine learning that probably for us they have features that can connect these two fields, our traditional fields, and why we use this technology. So we have some understanding of that machine learning, neural networks, and artificial intelligence, for example, have some problems. This is connected with the data sets. You need to have qualitative and big data sets, and some question about the AI technology has with the accuracy, not so big accuracy, and even has some big progress in algorithm and so on. If we can combine this technology with some other technology, we acquire some new technology. We can call this hybrid intelligence, and our traditional field is mathematical modeling. So mathematical modelings in the other side have great experience and reliability, and also methods of the mathematical modeling in prediction shows high accuracy. So combining these two approaches in some wise way let us achieve some great results. So how it works in the Arctic? So this is Arctic. We have a lot of we need to solve a lot of applied problems. So in this case, we think that some technologies need to base it on the fundamental level. So this is fundamental level is connected with some multi-scale methods, physics-driven machine learning. This is something like data adaptation for model and so on, data feeding and analysis and what's discretizations and splitting techniques and so on. We can combine in the scientific problems that all these technologies together in some applied technologies, and then we develop some integrated software toolbox that we can share between all researchers in our team. And we made some technological, not only technological, but also programming platform, that toolbox that can of our production that can provide us more concurrative advances. So in this case, also explaining what is our traditional methods and where we imply these technologies, but also so what is the hybrid intelligence? Hybrid intelligence, that means that some predictive work we correspond to mathematical modeling, and some predictive work we correspond to artificial intelligence neural networks. So we can see that neural networks can work good with data, and for example, pre-processing or inter-processing some technologies in modeling can provide by neural networks and machine learning. So in this case, we have some scheme. We combine these all technologies together, and this is our core and application research activities in our team. So this is and so on. And just as my talk not so long, so I don't dive to details, and in this case I want to show just some results of our little groups. So this group led by Maria Vasilyeva, they compute poroelasticity fractured method, for example, for oil and gas extract. This is some mechanical deformation in mechanical deformation in stressed bodies. This is a lot of technical issues. This is biomedical, some designs, for example, blood flow in some organs and biological structures. And here you can see the thermal flow in permafrost, led by Stepanov Sergei. And also we investigate some nuclear reactor processes. And here you can see object detection, filters. This is this work how to say, this work could make it in Germany, in University of Professor Iliev. And also we have some multi-physics applications where not only where we can see the complex physics that connects flow, elasticity, thermal processes, and so on. And a lot of works, actually, I don't have time to explain them all. So what our connection is before the COVID time, so our connection with the other research groups in other countries, for example, Seoul National University, Hong Kong Chinese University, Changsha University, Shenzhen University, a lot of Chinese university actually, and also Herzey University, and also we connect with the Texas University or University of Kaiserslautern from Germany, and Nuclear Safety Institute of Russian Academy of Sciences. A lot of foreign teams that we work together, and also some people from these universities also visit our university with someone with long time internship. And here you can see some grants of our team. One of the biggest one is it is mega grant, and maybe we have some joint grant in Russian Scientific Fund with foundation with China, and also we have on the other foundation we have a joint grant with Vietnam. So I'm ready to answer to your questions. And before I answer the questions, our domain field is the computer science and, for example, computational mathematics and mathematical modeling. So in this case, we apply artificial intelligence like a tool for increase effectiveness of our approaches and methods. So I'm ready to answer to your questions. Thank you.
Okay.
Okay. Someone have?
Yeah.
Okay. Thank you.
Yeah. I have a question. Yeah, actually.
Okay.
Yeah, I mean, basically you are mainly using some of the numerical model, right?
Yeah, Okay.
Yes. So is any, I mean, do you have embed or incorporate some domain knowledge based on artificial intelligence or some machine learning? Try to, yeah, you know, to improve your you know, your
numerical approaches.
solution.
Yeah, I understand. So this is actually we do in many ways how we improve our approaches, numerical and so on. For example, and do you know have explicit and implicit schemes, for example, for multi-continuum model, and where we have some strong heterogeneities and complex behavior and so on, we can calculate it on some how to say artificial intelligence pre-learned technology that provide fast, robust solution, and where we have the other continuum where we can compute directly, for example, by explicit scheme or so on. We combine, for example, learning on implicit scheme for one continuum, and we just apply direct solution on the explicit schemes on the other side. So, and in the end, we derive some partial learning technology, hybrid intelligence technology, and so on. But this is just one example. We have a lot of other schemes how we combine together these technologies, because this is very powerful and very effective in our field in computer science.
I see. So, I mean, you mainly for the diverse application for the Arctic problem, right? So, I mean, do you have pay attention to some extreme weather problem or some extreme maybe cold problem?
And this all problems, for example. Okay, can I show you?
Yeah, sure, please.
Okay, a few seconds. Yes.
Yeah.
Okay, this is thermal flow in the permafrost. You can see on this picture.
Yeah.
And actually, this is a real building. And here you can see artificial frozen systems in some building. Okay. And ground, actually, there is a big problem with ground in our region, because when the temperature go minus 60 to plus 35, this is very big difference, and ground tends to move. That's why we need to freeze some technologies, and we model for buildings in this field how this will be frozen ground, and to stabilize our ground between the buildings. So this is actually work connected with building, work connected with the geology and so on. And also when we want to extract resources from the ground like oil and gas and so on, in temperature we need to model not only in deep everything okay, because temperatures over there okay, but when we extracting and transporting and so on, we also calculate problems connected with the low temperatures when we have this season. So actually we consider a lot of problems connected with the Arctic region, with our region and so on.
Yeah, very interesting. Yeah, good.
Okay,
yeah, maybe we
thank
can
you.
talk
Thank
more
you
later.
for
Yeah,
your question.
yeah.
Okay.
Yeah, thank you.
Okay, so let us continue our program, our schedule. Please, you professor, associate professor from Liaoning Engineering Technical University. with his talk.
Okay. Thank you for the moderator, Professor Alexander. Can you hear me?
Yeah, we can
Yeah,
hear
we
you
can.
and see you.
Okay, thank you. Now I'm sharing with my screen of my presentation slides. Okay, can I start?
Yeah, please.
Okay. Dear colleagues and audience, good morning and good afternoon. Thank you for your attention and to listen to me. And my name is Yue Liu, and you can call me Liu for short. I come from Liaoning Technical University, Liaoning Province, China, and it is really honored and glad to share my research on the optic electric materials research on the forum. My research topic is research and application of thin film in fiber optic communication, communication moderator chip and industrialization. The content will be reported as listed above. The first is the basic experience about myself, and the second is the project implementation status, and the third is the basic information about the enterprise that were based on our developed materials, lithium niobate thin films. Here is me. I graduated from Nankai University, and my bachelor and PhD study is about the optical electronic materials. And in 2014, I worked in Rutgers University in Emergent Material Center. And in 2018, I worked in Padua University from new material research. And this year, October, I joined a company which is named Huayue New Optical Electronic Materials. And our research has been funded by Suzhou Wujiang District and a new science and technology competition in 2022. And I have published some scientific papers and selected as a guest editor in Frontiers in Chemistry journal. And then is my research background about thin films of lithium niobate chips and the modulator, and it has four aspects of barriers for the development research about the lithium niobate thin films. The first is the connection, is the concentration of iron ions, which is easy to aggregate during the growth of the lithium niobate crystal in the thin films during the growth. And the second is the parameter matching during the ion beam etching, which is to reduce the thickness of the lithium niobate thin films. And the third is lithium niobate thin films thickness monitor during the etching. And the last barrier is the surface brightness of lithium niobate thin films during the preparation. So to solve the barriers, we offered a product. Our core product of this project is iron-doped lithium niobate thin film chip, and which can ensure the uniform distribution of iron ions in the thin films and reduce the thickness of the thin film to the level of 100 nanometers. In the pictures, we can see is the lithium niobate thin films, and which the different colors.
Yeah, your PhD didn't, your PowerPoint didn't, didn't move. Okay.
Oh, it is suspended. Okay, it's this one.
Okay. Maybe you need to share your full screen when you share your whole screen.
Okay.
We can see.
Can you see it?
Yeah.
Okay.
But
Okay.
you can show previous slides for us.
Okay. Sorry. This is the content. Should I start here? Okay, this is my basic experience about myself. I graduated in Nankai University and worked in Rutgers University and Padua University, and our research has won some prize about science and technology entrepreneurship competition, and something about the research publication. And the research background is the lithium niobate thin films, iron doped chip and modulator, because the demands depends on the import. Globally, the production enterprises of thin film lithium niobate chips and modulators are mainly from the XBlue from France, and OptiLab from United States, and the Lumentum company from United States, and Fujitsu from Japan, and another few enterprises which is fabricating the lithium niobate thin films. And the four barriers is from the ions concentration, which is easy to aggregate during the growth. And the second is the parameter matching of ion beam etching during the FIB technology to reduce the thickness of the films. And third one is the lithium niobate film thickness monitoring. And the last one is the surface flatness of lithium niobate in films after the growth, because we need to use it in optic research. And the core product is listed in the picture. We can see that the different color is because that the different element doping. For example, the transparent one is the pure lithium niobate substrate, and we can see if it is in the middle. This picture, because it is the dark one and not transparent, because the substrate is I think it's silicon or something that is not transparent. Mostly is silicon, and the thin films is deposited on the silicon like this way, and it's mainly used to make high performance modulator, filter, detector, crystal oscillator, and high density information storage device for communication. And the core technique including four aspects. The first is the iron slice preparation technology, which can prepare good thickness of the thin films. And the second is the parameters prepared during the etching. And the third one is the flatness after the etching, which can influence the loss of the signal noise. And the last one is the electro-optic testing technology, which can measure the photocurrent until 10 nanometers ampere. The first one we can see is to make the iron slicing preparation. The second one is the surface loss photoelectric materials. And third one is the surface flatness. We can see the picture is made by the AFM. And the last one is to measure the optical electronic signals, which is to show the behavior of the thin films when transfer the light signal into the electric signal. And we compared our product to the Jinan company, Jingzheng and Fujitsu, and it had a better performance in the loss conversion, thickness, roughness, and refractive, and other parameters. And we have some intellectual property related to the thin films fabrication, and in the future we will try to renew it.
Ну, чё,
And,
ну хотя бы так, да. Мгм. Так, одним ниже.
Он скреплен в производстве.
And in the future, I want to
Да,
also
всё
to
вставлю,
devote
хорошо.
the research in
До
the
свидания.
Arctic field, like to measure it in the low temperatures aspects. And here is my topic. Thank you.
Okay, thank you. If we very strictly limited with the time, so just one short question, please, if anybody has. Very interesting topic, but we don't have enough time for discuss.
Okay, thank you for the moderators, Professor.
Oh, okay, thank you, Yuli, again.
Okay.
Next talker, Tunichkin Ilya. Tunichkin Ilya. Okay, then we cannot see him on the section 1, so I think we take his time. So the next one, Yulu. Is it here, Yulu? Okay, if they connect later, we can, I think we can change them. But right now, let me introduce Kruglikov Sergei Vladimirovich, head of Laboratory of Applied Researches Systems from Ural Federal University. He has talk. Sergei Vladimirovich, please, your talk.
Добрый день, коллеги. Я могу говорить по-английски, могу по-русски.
Good afternoon, dear colleagues. I can speak Russian, English. Which language do you prefer? Please tell me. We have interpreters, so it's your choice. Okay, so please turn my presentation on. But for starters, let me give a small announcement. So you will speak Russian, right? Yes, I will. It's okay. So I am from the Ural Federal University in Yekaterinburg, and the topic of my research is connected to implementing numerous methods within the project of Smart Arctic City. When we think about our research, we understand that the most useful and important moments are distinguishing the correspondence and the coordinates according to the 17 United Nations Sustainable Development Goals. You can see them on the web on the slide, and we have highlighted in yellow the basic goals that are, to our opinion, very important when working on the smart city in the Arctic project. This is, of course, ensuring healthy lives and promoting well-being for all at all ages. This is, of course, ensuring access to affordable, reliable, sustainable, and modern energy for all in the Arctic. This can be connected to living conditions of people, of course. Next, building resilient infrastructure, promoting inclusive, sustainable industrialization, and fostering innovation in the Arctic. This list defines the goals and the values that we want to reach in the future. Please, next slide. The correspondence of valuable conditions that we have defined on the international level, they correspond with the main goals that were included into by government and the president of Russia. Underlined in this slide, you can see the main points that are related to developing cities and other settlements with the urban economy, energy infrastructure, and application of digital technologies as basic technologies that ensure well-being and efficiency of work. When we were dealing with the basic approach to the Smart Arctic City project, on a very certain example that I will talk about later, we have found out that the understanding of the Smart Arctic City project means corresponding hierarchic goals related to 4 components: environment, society, business, and governments, with how we regulate all of it. This scheme is found on each level. We have defined these levels based on basic values of the UN, and we understand that this scheme can reach a level of every single citizen of a city. The standards, whose standards of living are defined with the requirements of modern conditions. This opinion is
при практической работе, связанной с расположенным на полярном круге городом Салехардом, административным и экономическим.
The administrative center of one of the basic regions of Russia, Yamal Peninsula. Yamal is a region where the production and the trade implemented, the trade of energy, oil, and gas. We are interested in Salehard as an application for our technologies and applications. So Salehard has been developing according to the strategy adopted adopted until 2030. This municipality has all the funds necessary from the okrug or district where it is located, which is a basic source for Russia and the world, and of course gets funds from federal budget. So the city has all the funds. That's why we can think about implementing effective projects. We have conducted an analysis which showed that the applications and definitions of effectiveness from the perspective of the Arctic Smart Cities project includes 3 possible scenarios to solve the problem. Each scenario can be on a different level, can be effective, and can lead to certain results that were included into the development project. The scenarios include alternative scenarios, technocratic scenario, and innovative scenario. We have looked through each scenario based on the example of Salehard city. As a result, we have reached a multi-agent controlled system to ensure the city, to provide the city with heating, which made us sure in defining main points and main issues that occur within the city. And based on that, we can foresee the effectiveness of each possible scenario. So intertial scenario includes long-term priorities of socioeconomic development of the Salehard city, which is a very important point of development. This is the peculiar thing of this scenario is that digital technologies development is one of the main priorities. However, in the numbers of this development, they are distributed based on the times and time periods, which do not include the goals and the results, only numbers. So this led us to the results where we can save some heating, some water, without losing or worsening living conditions. This scenario led to reaching economic goals. However, the main challenge of this technocratic scenario, innovative scenario, was that we had to correspond interests of all the processes. First of all, the government, the business, and the society. Each participant had its own interests and the correspondence of their interests when implementing the most effective strategy or scenario could not ensure the correspondence. That's when we had to find corresponding and new scenario that would include all interests of all the participants. And this scenario was suggested. This scenario is being discussed now. And in this scenario, apart from just looking at mathematic models related to analysis of sustainability of engineering structures on the permafrost, managed by energy consumption, hybrid electricity, and implementing beam technologies. The foundation is that the basic point for the implementing this project is need to ensure manageability and its modernization within the city. However, the manageable scenario should include the interests of municipality bodies and the government bodies. However, we managed to find a solution to that. And this solution was based on correspondence of engineering technologies and social technologies, organizational technologies as well. That would be the basic model that we have suggested. It was based on the issues related to permafrost degradation that are taking place in Salihard, because Salihard is situated in unconventional location, and the permafrost in Salihard can happen very fast if the heating is very strong. So the suggestion was during the solution was to give cooling waves into the permafrost under the buildings in summer period. So now this project is being discussed, and we hope it will be implemented in the city. So when we speak about the possibilities for cooperation, we think it's a very important scheme. You can see it on the slide. So this is a corresponding scheme of presenting 17 goals of sustainable development defined by the UN, and they are based on the global harms and the technologies related to ESG. You can see 3 arrows on this scheme. They show the direction. They show the 3 directions which we can take into consideration and define the business responsibility in modern conditions. However, corresponding activities, corresponding work requires not only business responsibility, but also the government responsibility when interacting with other components of this scheme, and the responsibility of the society as well when integrating with other participants of the scheme. So we think that such approach when modeling the processes of development and searching for balance, sustainability, means we can find a solution, and we can organize international cooperation and take into consideration interests of each party. Thus, the goals defined by the UN, they show a very sustainable system of coordinates where all the interests of each party can be related to 17 directions. And you can find the aspects, the technological aspects, where each participant has all the necessary knowledge and capabilities. So thank you for your attention. We are open and ready for cooperation and ready to answer all the questions. Thank you so much.
Colleagues, 3 questions. Okay, if nobody have questions, I have one. Professor Kruglikov, what you understand in meaning of smart city in very short term? how you can explain this term smart city very shortly?
С моей точки зрения, то, что мы прячем за термином...
From my point of view, what we are hiding behind the smart city term is the understanding of the continuous goal-oriented modernization and step-by-step increasing of efficiency of a city as an integrated system, as a whole system. And from one point of view, the defining point here is the need, first of all, for creating the management modernization, and then after that, provide the technological foundation. We, for each specific city, identify the issues that they have, try to find out solutions to these issues in the interaction of businesses, government, and society, and then propose technological solutions to these issues, including digital solutions. Digital technologies are the basis foundation for collecting and gathering data, so that later, using the database technologies,
Okay, I see. Давайте я вот...
является самоцелью. Он является...
And this is the goal. This is the tool for solving the issues that provide a good quality of life. We expect that for a small city, which is located on Yamal, next year, we're going to start implementing a step-by-step project. This project that slowly increases the level of the city to a higher level. Okay, and one thing that I want to clarify, because this topic is very interesting for me, because we have applied for a grant for a smart city, but didn't win it, unfortunately. And in your presentation, you said that one of the key technologies, in addition to data collection, BIM technologies, etc., is the mathematical modeling and predictive technologies. Why do you think that these predictive technologies are such a foundational component for smart city technologies? We talk about predictive technologies in general, or predictive technologies from the point of view of permafrost, because we have two aspects that I looked at. Okay, so let's from the point of view of permafrost, because it's connected to our region. When we talk about smart cities, we also talk about the possibility of manageable modernization. That is the creation of a management for an organizational system, which is the city, where people manage people. And this management is not possible without predictions. Prediction for at least 1 year, and even better for the next 3 years. And when we talk about permafrost, then we need to create our technologies taking into account future climate changes, which are accelerating now. But these are the calculations for at least 10 years ahead. And the issue here is connected with the fact that the situation changes very fast, very quickly. And the technologies that we are going to select now, they should not make the situation worse in the future compared to what we have right now. That is why the possibility of making predictions is necessary, mathematical modeling is necessary not because we love equations or we can make them, but so that on the basis of the experience that we have gathered to see the trends. And our art is in making the trend to be confirmed by applied results. And when talking about the modeling of permafrost in our university, for about at least 20 years, we have a very active group connected with the prediction of heat distribution in permafrost, and we worked for the oil producers, because you probably know that the oil comes from underground, and it is a kind of a mix of at least 80 degrees centigrade. And when we mine oil, extract oil with this technology, the permafrost gets warmer. And this is like a continuous process. And that is why we were working on that to try and stabilize the permafrost. Yes. Okay. Thank you very much for your very detailed answer. And maybe Nor-Nickel company probably should introduce the Internet of Things and like the sensors and so on, and maybe they wouldn't have had this accident some time ago. Yes, so when we're talking about the process of heat distribution, we are talking about this. We are getting the raw data from those boring areas. And well, we get it from Yamal while we live in Yekaterinburg, and it's like 1,500 kilometers away. And this is the Internet of Things that's helping us to get this data. Thank you. And the time of our section is now finishing.
Finish it. And right now I want to introduce Savinova Antonina Nikolaevna. This is a moderator of the section 3. Antonina, are you here? Okay, so right now we don't see Antonina here. In this case, I think I can continue moderate section because time already will start. First talker from Dalian Technological University, Professor Lee Chizun. Are you here, Lee Chizun? Okay, we can wait very short time for moderator, and we can wait for Professor Lee Chizun. But anyway, for information, once in Wayan I don't see in my section, so I skip this talker. Maybe he has the other account with not his name. One Sinway. Oh, okay. And the second speech is should be provided by Dyomin Viktor Valentinovich. Are you here? Okay. Antonina, is it you? Antonina Nikolaevna. Yeah. Let me introduce the moderator of the section 3, Savinova Antonina Nikolaevna. Thank you.
Начинаем, да, третью секцию?
We're starting section 3 then. Good afternoon, dear colleagues, and we are starting the work of the section number 3. Environmental protection and bioresources. According to the program, we have 9 speeches, and the time limit for each speech is 10 minutes and 1 to 2 minutes for questions and discussion. So if we start with presentation, our first speaker is Lee Ji-jun, professor, Dalian University of Technology, who is going to be speaking on the studies of the influence of physical environmental factors on the ecosystem under the ice. Professor Lee Ji-jun, the floor is yours.
Есть у нас, да, Ли Чин-сюнь, Далянский технологический.
Is Professor Lee here? Professor Lee Ji-jun from Dalian University of Technology.
По-видимому, нет. Тогда переходим к следующему спикеру.
Seems he is not here, so we are moving on to our second speaker, Dyomin Valentin Viktorovich, first Vice Rector, Tomsk State University, who's going to be speaking on the estimation of the Arctic ecosystem state by plankton investigation with the use of underwater digital holographic camera.
Мы начали чуть раньше, потому что предыдущие секции.
Yes, we have started slightly earlier because the previous section stopped. Okay, so we can maybe wait a little bit then. Okay. Let's wait a little bit. The presentation is going to load and then we can start.
Есть перевод? Переводчики есть, ага, есть. Можно по-русски, да?
Давайте буду по-русски говорить.
Да, давайте еще раз объявлю.
Okay, so I'm going to be speaking in Russian. Viktor Dyomin, first Vice Rector, Tomsk State University. Good afternoon, dear colleagues. I don't see my presentation yet, and I'm going to start speaking before it's on. And the topic of the presentation has been said already. And the first place is going to show that the digital holography of particles allows for registration of the environment where the particles are of any nature. This can be plankton particles or gas bubbles or oil drops, any type of medium. Yes, I can start, yes. So, thank you. So this is what I've been talking about, my presentation in English, so it will be easier for our colleagues to understand. So when I was saying that when we reproduce the image, in general, we can see the images of each particles that were inside those things. When we talk about digital holographic methods, there is also the possibility for transmitting this data, this holography. So we can use it using cameras. And we can transmit these holograms using the 2D arrays through mobile connection. And we control our equipment using mobile connection as well. And the second pro of the holographic method is possible to make a holographic video or a video that is based on holographic data. And as such, we can research the dynamics of particles. And as a result, after the reproduction of one hologram, we can see the images of all particles. And in our software, it is done automatically. And we can register all places where those particles are located, their coordinates, their shape, their size, and can recognize them, which is also done automatically. And after that, this information can be represented as a distribution by size, by layers, and so on. And when we register not one hologram, but the hologram within a time frame, then from each of these holograms, we can reproduce the image of the particles that we're interested in. And then while combining, and after that, by combining those holograms, we can get a video. And here you can see we made it for a large particle, which is outlined in red here. And as you can see, it can be done for smaller particles as well. And here there's a video based on holographic data, which has been done completely done by automatic processes. And you can even see some pixelation here, which is a result of automation. And in the end, we can work in two regimes of work, of using holographic methods for underwater registration of particles and for estimating the state, the sea basin. So these are the spatial registration or temporal registration. And you can see here on the slide how it's being done. And this is usually done from a sea vessel or any moving platform. And it is also, while we're doing the registration of temporal type, it's usually stationary stations. It can be either like a floating station or the stations which are on the bottom of the sea. And then we can get all this data like the concentration, the biomass, and we can estimate the transparency of the medium. And if we are like taking into account methane, we can see the amount of methane being emitted. So all of the investigation is done in situ. So we are not taking the particles away from their medium, from their environment. For example, plankton is still in the sea while we are doing these measurements. And we have these options for holographic sensors, as you can see on this slide. And here you can see how we are doing the measurements on these particles outside the water when we just gather these particles, and then we can study them under a microscope. And here you can see on the left, the second photograph is the hydrobiological probe with mini DHC, which is lowered into the sea. And so I think there are some strange sounds, but not for us. So we have tested our equipment not only in laboratories, but also in real conditions. We had many different Arctic missions, like the Arctic mission in the Kara Sea, the experimental study in the Kola Bay, the Black Sea, the Lake Baikal, and so on. All of these expeditions that we have seen, and they have all shown that our equipment allows for estimation of the state of any particles in any water basins. And for example, when we have this example, when we record the concentration of the plankton, the temperature regime, and so on, and all these holograms can be sent up to the ship, and we can make these holograms based on that data. And these are the examples of all these particles that have been taken on various expeditions from the depths of like 100 meters, 200 meters, and so on. And our equipment is can work at the depths of up to 500 meters. And we can use it at even deeper depths as well. And you can see it's quite possible to identify any particles. So the sizes here are up to 100 micrometers and higher. And here, we haven't talked about DHC. What is this? And you can understand it's shown here. It's a digital holographic camera. And here we have this equipment that is used for attracting plankton. And this is the green light here, which is the color of algae that the plankton eat, that they feed on. And we do this, why? Because plankton, it eats and filters through lots of water. And that's why they're extremely sensitive to any pollution in water. And that is why we propose to use it for early detection of pollution in water basins. And here, these are the three possible applications for DHC sensors. First is the monitoring for fishery, second for biodiversity monitoring, and to estimate the evolution of water's ecosystems, including seawater areas, internal reservoirs, and of course the monitoring and early protection of hazardous ecological conditions by means of bioindication. And this is especially important near some dangerous objects such as nuclear power plants, oil pipelines, and so on. We are producing this equipment for many different bearers, such as these submarines or self-floating buoys, bottom stations. We are also discussing the possibility of creating underwater observatories, which would allow for plankton monitoring in order to estimate the state of the environment in these regions. And here you can see a number of examples of underwater observatories that are already operational, such as the observatories near Canada. And there are also stationary underwater observatories. And you can see that they are mostly in the Atlantic Ocean. And you can also put sensors of oxygen, sensors of tsunamis, sensors of chlorophyll, and so on, and in such a way to estimate the state of the environment using these sensors. And plankton sensors should also be present there to help in early detection of seawater pollution with a great deal of accuracy. And we've been talking this with our colleagues in Sakhalin, and it's possible to set up such underwater observatories, for example, in oil drilling platforms and so on. And here you can see a number of publications that we have done on this issue, and this presentation will be available to you, so you can always find it this. And in conclusion, I would like to talk about something different, that at the moment we are organizing an international forum where we are inviting association and consortia of northern regions which are interested in Arctic studies. We think it is very important for us to meet with and to discuss with others the directions, research directions that they are working on, so that we can understand how can we cooperate with each other, how can we work with each other, how can we eliminate maybe extraneous efforts, such as everyone works in cooperation and together. And here you can see the information of this international forum. And we have here these partners at the moment, the National Arctic Research Education Consortium in Arkhangelsk, also TASS, Russian News Agency, and the Consortium of Arctic Research, which was created yesterday at the signing ceremony. And many understand that this is already need to be done. And this is one of the goals of the forum that we're going to be holding in Tomsk on April 2022 next year. And the main goal of it is to create cooperation between different consortia, different associations, and we will be very happy if you take part in this forum. And if you want to take part in it, please contact us and please tell us what to do. And at the very final conclusion, I want to talk a bit about this place. So it's being done at the venue of the forum. It's the Tomsk State University. It was established in 1878 as a Siberian Imperial University. It was the only university in the Far East in Siberia at the time. So many Arctic researchers of that time, the early ones, they started their education there. And it will be nice for us to take part in the forum and celebrate in its anniversary. Thank you very much, Viktor Valentinovich. If there are any questions, please. It's a very interesting speech. And I want to ask, so you talk about the minimal size of the particles. What is the maximum size of particles that is detected by your cameras? It's 40 millimeters right now, because we're using these lenses with a diameter of the light beam of 40 millimeters. Of course, depending on the specific task, we can change the sizes, we change the specifics, and it is possible for that, we will need to change the size of our cameras because it depends on the wavelength and so on that we are using. And we can use this data for creating graphs of distribution, and we can increase the representative status of our measurements. And the camera is your development completely, including all its parts. Yes, most of the components are sourced from China at the moment, it's the matrix of the camera, but everything else is produced in Russia. Thank you very much.
Соответственно, вы рассматривали так или иначе.
So you have been looking at plankton. So the issues that you had with red algae in Kamchatka, did you have something like that in your research? Well, no, we didn't really have something connected with that, but we did discuss this with the Ministry of Natural Use and Ecology of Kamchatka, with the minister, and especially in connection with red tides, high tides, we discussed the need for integrated monitoring, and our consortium is quite large and we have quite a lot of competences there. So as such, we are planning to measure not only the zooplankton, but also monitor the chemical composition of the sea and the oxygen, and also maybe put up seismological sensors and so on. So we're saying that we need to get as much data as possible. It's just at the moment we are not sure which parameter is the most important. That is why we're measuring almost everything. So yeah, the question is like, what about the prognostic capabilities? Well, yes, it's possible that our technology might help with the early forecasting of disasters. Thank you. Thank you very much. So let's return to our first speaker, Li Shisun, professor, Dalian University of Technology.
Полагаем, что профессор
I think that professor is not here yet. So maybe we on to the next second, our third speaker, Zhang Zifeng, associate professor, Harbin Institute of Technology, Polar Academy, Harbin Institute of Technology, and Arctic Research on Environmental Ecology in HIT.
Okay. Hello. Can you see the screen?
Yes. Yes.
Okay. Okay. So I'm very glad to be here to give a brief introduction about our Polar Academy, Harbin Institute of Technology, and some our Arctic research on the environment and the ecology near our university. My name is Feng Zhang from Harbin Institute of Technology, School of Environment. So today's presentation, I give two parts of my content. The first one is the brief introduction of Polar Academy. So as a consultative party to the Antarctic Treaty and contracting party to the Spitsbergen Treaty, China firmly upholds the proposal of these treaties, protects the Antarctic and the Arctic environment, advocates scientific research, promotes international cooperations, and strive to make due contributions to the growth of human knowledge, progress of social civilization, and sustainable development. And our Polar Academy established in 2018. Our Polar Academy aims at the frontier of polar science, relying on the multidisciplinary integration of 12 national top-level disciplines, such as environmental science and technology, and physics, civil engineering, architecture, transportation engineering, biology, and food science and engineering in our university. There are 6 research centers in Polar Academy of our university. So our research center named Arctic International Joint Research Center for Arctic Environment and Ecology. So there are 5 research directions here. The first one is the impact of climate change on the Arctic environment and the ecology. The second one is global POPs emission residue list and the impact of global POPs emissions on Arctic eco-environment. The third one is monitoring of POPs and its temporal and spatial trends in large scale multimedia environment or globally or regionally. The fourth one is screening, quantification, migration, transformation, and fate of organic pollutants in the Arctic multimedia environment. The last one is mechanisms of POPs transmitting to the north and the south pole over the long distance through the atmosphere or ocean currents. So there are 5 research directions. Our chief scientist is Dr. Li Yifan. As well, our Polar Academy, we established Harbin Institute of Technology, Heilongjiang Meteorological Bureau Mohe Polar Stimulation experiment base. So this city is the northernmost border of China. The lowest temperature reached -50s, and meteorology, biology, and electromagnetic environment in the base are similar to the polar regions. So we have some simulations experiment to do in this city, in this area. So here's the location, the northernmost border of China. So connect with Russia. So here's the second part is research, Arctic research on the environment and ecology. So right now we have because both of our university and some of the our partners such as Dalian Marine University and the Northeast Federal University in Russia, we have established a network from Arctic network, U-Arctic network. So here's the title of our project related work is chemicals and climate change. So we have established the monitoring network from Arctic to the north of two cities in China, Mohe and Harbin, and the last one is very south of China, is Shenzhen. So we have 6 locations and the monitor network in both in China and Russia. And the other one is we have cooperation with Norwegian University of Life Science in Norway. So our partner is Dr. Roland Caliber, and we have detected the bisphenols compounds in multimedia in Longyearbyen, Spitsbergen. So here's the locations. So Svalbard. This is Svalbard. The capital of Svalbard is Longyearbyen. So we got like oceans and soil, leachate, and air, and fish delta samples along the sampling size here, and we detect these emerging contaminants in these multimedias and research the characteristic, and some of them have the bioaccumulations. So here's some of our result here. So we maybe 2 or 5 days later we will submit this manuscript. So we already done this work here. And besides, 5 years ago we have our leader, Dr. Li, has published one paper in ESNT. Here's the ESC paper. This journal is top journal in our field. So the name is deca-brominated phenol ethers in Chinese and the global air levels and the gas particle partitioning and long range transport. So this is the like a novel series of our doctorate's research. So it's top like ERS center is the top research here. So it's this paper we got very good effect in the in this field. And almost 15 years ago, we got an international polar research polar year project, the intercontinental atmospheric transport of anthropogenic pollutants to the Arctic. So we had something and detection work in Wudalianchi and Valiguan and some Shuancheng, and here's the location. We got some background samplings and detect the anthropogenic pollutants in these background areas. So this is our first research about Antarctic. And besides the Arctic work, we had some research work on the Antarctic. So we have published 3 top papers in water research and environmental science and technology about our snow dragon boat collect some air and seawater samples from Shanghai to the Arctic. So that work is about those works were about the Antarctic research work. So I did not list on these slides. So here's just a brief introduction about our Polar Academy and our research, Arctic research in our universities. So I hope if any scientists or professors want to cooperate with our Polar Academy, and can send email to me directly. So welcome all the scientists to our center, and maybe we can work together in the future. Thank you.
Спасибо, уважаемый Чан Зефень. Я бы хотела отметить то, что мы...
Thank you so much for your presentation. I would like to say that we have a long cooperation with Harbin Technology University. We have your other colleagues from these universities. Some of your colleagues have also visited us during our first forum of the association. You also had an expedition together with us in 2019, and I think we have a very productive cooperation. So I would like to encourage our other colleagues from other universities to cooperate with you. So please, colleagues, if you have some more questions to Professor Zhang, please ask. Okay, so thank you. I would like to give the floor to our next speaker, to Samarina Vera from Kola Science Center of the Russian Academy of Sciences, with her report on sustainable development of the North, legacy of ultra-deep drilling of the Earth crust.
Good afternoon, dear colleagues. I'm very happy to be at this conference, and I'm very happy to congratulate you with such interesting reports. And unfortunately, I didn't have opportunity to come to Yakutsk. I was planning to come to Yakutsk in September, but it didn't work out, unfortunately. But I'm hoping that this is not the last time that the forum is being held, and that next time I'll be able to visit you in person and meet you all. And now I'm going to show my presentation. Can you see it? So I'm going to talk about sustainable development of the North, the heritage of ultra-deep drilling of the Earth's crust. And my co-speaker is Vera Samarina, Piotr Skufin, Doctor of Geology and Mineralogy, professor who for 62 years since 1960 worked in Kola Scientific Center of the Russian Academy of Sciences. And for many years, he's been working on research connected with ultra-deep drilling. And he is my father. And this is our joint speech. He's 85 years now, but he's still working and he's writing articles and so on. And the idea of ultra-deep drilling appeared in Russia in the 1960s. 1960s is the period when Russia became the first in space. And maybe you know that we have been there like earlier than the Americans for a few hours. And this idea of dominating everywhere was in ultra-deep research as well. And if we look at the way space has been explored around us, and the way the deep Earth has been explored, we can see a great difference. We have a lot of data about space, while we don't have almost any data about the Earth's crust, and there are many things that we don't know about it. And the research started 60 years ago, and it's still going on at the moment. And in total, 12 basic ultra-deep holes were planned for boring in the most important regions of the country. The mineralization was to be researched and to try to go as deep as possible. And from these boring holes, most of them are closed right now due to technical difficulties. And ultra-deep boring holes, there aren't that many of them around the world. Only about 7 in the world, and none of them went deeper than 9.5 kilometers. The Kola ultra-deep boring hole is the deepest hole in the world, and it went down up to 12,500 meters. And there is another one in United States at the moment, which length is longer than the Kola hole, but it's not the deepest still. In the northeast of Soviet Union, in Murmansk region, a unique Kola ultra-deep boring hole was started, and it was planned to go deep up to 15 kilometers. And it was done in this ore mining region where many deposits have been mined for hundreds of years. The deposits of cobalt, gold, silver, nickel, and so on, consisting of different layers of sediments. And the boring hole was in a new place where a road was built to, and about 3,000 people were involved in this project, headed by Alexander Nadelmar. And 19 research institutes took part in this work, and a big complex was constructed there, including many research laboratories, and the buildings with the boring hole and the dining room for 120 people. And this was a advanced technology installation and had this drilling equipment in it. You can see it in this picture. And all of this was controlled during the process of boring. And all the drilling equipment and the measuring equipment was made in Russia. All the technical and digital electronic equipment was providing the safety, was ensuring the safety of boring. There are, of course, many different projects, the space projects, ultra-deep boring projects, which are only possible if only all the resources of a country are used. In modern conditions, unfortunately, this kind of research is not possible in Russia. But at the time, this was done like that. And the best minds of the Soviet Union were involved in this. And this project was a secret one. It was classified, even though lots of companies were involved, lots of people were involved. Nobody knew about this project. And for the first time about this project, the world community learned in 1975, when in Pravda newspaper, an article was published. And before that, there was, and until the dissolution of the Soviet Union, there has been no research papers published from the results of this Kola boring hole. Only after that, it was published. And slowly, the country learned about this unique project. In 1984, the first monograph about the Kola ultra-deep boring hole was published. This project became the flagship of research superiority. And this was a multi-kilometer telescopic construction. And the drilling continued until the deepest layer was reached. By 1990, the drilling should have reached the depth of 13,000 meters. And at some point, when the drilling was started, the depth records that were set previously in other countries, such as the United States, they have been broken many times. And the difficulty started to increase as the depth went in. The temperature at the lower end reached 220 degrees centigrade. And this has led to many different difficulties with the equipment, because it was breaking down and the electronics were breaking down and everything was like not easy. And this has led to the necessity to use specialized equipment. And this has led to the fact that sometimes the drilling equipment will break down and will get stuck in there. That is why the people who were involved in this, they had to start drilling new holes, new shafts. And the dips, these holes that were abandoned, they will be filled with cement, and then the new ones will continue. And at the deeper depths, there were like about 5 different shafts, and you can see it on this picture. In 1990, we have reached the depth of 12,216 meters. And the researchers, they were prepared to drill down to 13,000 and 40,000 meters, but the drilling equipment broke again, and the government decided to stop the drilling. In 1990, the drilling work was stopped completely, was finished. In 1990, the company received the status of a research center, and the scientists of over 20 countries made some unique research under the UNESCO projects there and the International Geological Union. Unfortunately, after that, due to financial issues, the Kola ultra-deep geolaboratory was decided to be closed, even though their research would result in millions of dollars of profits for the country. with some small investment, only 3 million rubles a year. In 2008, the building was put into conservation, equipment was deinstalled, and some of it was scrapped. And as you can see, everything turned into ruins. This is how it looks like right now, this unique construction building. And this is what is left from the boring drill. Only this welded hole with a sign that says 12,226 meters, which is a unique record which has not been surpassed up to this day. So what is the most important thing of this ultra-boring drilling hole, and why is it important for sustainable development? The fact is that the company basically met all its goals. 4,224 meters of layers, soil layers, was extracted from this hole, and lots of information and data was received about the state of the Earth core, and new information about the temperature and the composition, physical and geochemical properties of deep ore layers was received. What is the most important? And it turned out unexpectedly that the deeper the boring hole was going in, and the deeper these researchers were looking at, the more sudden and unexpected were the findings that they were making. So before this hole was being drilled, it was expected that the Earth core will be more dense at depths, but it turned out that at high depths, the Earth core is porous and has many different cracks, and there's high temperature water circulates there under immense pressures. And this was a very unexpected find. And this had very significant consequences. And understanding of the fact that the Earth core is porous and littered with cracks inside and is filled with superheated water under high pressures is like extreme. It was very unexpected, and it's still like mind-boggling to this day. And back in those days, in 1970s and 1980s, there has been a project of French researchers to use these super deep holes for burying the nuclear waste. So what would have happened if we didn't find about these properties of the Earth core? Well, yes, just imagine all the nuclear radioactive waste would be being spread in this water, using this water all over the lithosphere, everywhere. And this will have led to nuclear pollution of great areas. And that is why the results of our research were published to prevent this kind of mistakes. And of course, in all these 12 kilometers, the chemical properties, the physical properties of Earth's core were studied, and many different deposits of these natural resources were found, which are difficult to extract now, but maybe in the future they'll be easy. So what are the prospects for this kind of ultra-deep boring holes? So it is possible to continue the work on this Kola ultra-deep hole. Well, in theory it is possible, but in reality it will be very difficult because we just saw that the complex has been abandoned and it's basically destroyed. But the data that we have received, the skills that we have received while we were doing this, the technical skills and the equipment that has been used, it is still used today in many different applications, such as boring super deep oil wells, for example. It's being used in China, for example, because China is going deeper and deeper into the earth at the moment for finding new deposits of oil and gas. And of course, this survey for mineral resources is also being done using super deep drilling. So this is my report. Thank you very much for your attention. Thank you very much, Vera Petrovna. This was very interesting. If you have any questions, please do not hesitate to ask them. Thank you. So we now move on to our next speaker, Keke Shao, doctorate student, Beijing University of Technology, who is going to be speaking on experimental study on the distribution characteristics of trapped air bubbles during the freezing process of horizontal water film.
Можете начинать.
Please, Shao Keke.
Так, переходим к следующему спикеру.
So we move on to our next speaker, Елена Gogina, Head, Construction of Water and Sanitation Infrastructure Department, Ordzhonikidze Russian State University for Geological Prospecting. And the topic is resolving the issue of wastewater treatment in harsh climatic conditions.
Good afternoon, dear colleagues. Let me give some time. Do you need some more time to prepare? Yes, I need a little bit more time. So please go to the next speaker and then I will be able to present. Okay, so let us move to our next speaker, Zhang Yiwen, Dalian University of Technology, with his report on driving effects of physical factors on primary productivity in Eurothopic lakes during ice-covered period, a case study of Hanchang Lake near Bohai Sea.
Okay, thank you. Thank you, I'm here. Okay, the title about the phytoplankton primary productivity is the title I provided to the organizer in August. But the phytoplankton community structure is the work we are interested in now. So today I will introduce my study about the dynamics and the characteristics of phytoplankton community structure of lake during the ice-covered period. My name is Zhang Yiwen from Dalian University of Technology. I'm great honored to be here to give a presentation. Climate change is one of the issues to global lake ecosystems. Ice-covered duration and the surface water temperature of these northern lakes have already changed. The key physical factors will affect lake productivity and the ecosystem. Phytoplankton and algae are significant primary producers, and the phytoplankton community are organized as a nutritional or ecological indicator. They react quickly to the changing environmental conditions. Up to now, in winter, we have known that the lake under the ice also showed high primary productivity, and the phytoplankton community structure will change in winter between winter and the other seasons. There are also some studies to explore the relationship between the temperature and blooms. However, the changes of phytoplankton community structure during the ice-covered period were not clarified, and the factors driving the changes and the phytoplankton community are not explained. So this study, the aims of this study, the first, what are the changes in phytoplankton biomass or abundance and the community structure during ice-covered periods? The second is, what are the key drivers of the succession or evolution of under ice water ecosystems? This one is the research route, including field investigation and the library detection, to reveal the relationship between environmental factors and the phytoplankton. Study area is the Hanzhang Lake near Liaodong Bay of Bohai Sea in China, which is a salt lake. In the previous study, little attention was paid to salt lakes compared to the freshwater lakes. Salt lakes can reflect the change characteristics of lakes and the junction of land and sea. Phytoplankton are the main primary productivity in the Hanzhang Lake in winter. We choose two sampling points. One is in the center of the lake and another near the urban landscape river estuary. This showed the sampling and the detection methods. The ice-covered period of Hanzhang Lake is more than 85 days, and the ice thickness finally reached 40 centimeters. According to the growth of the ice, we artificially divided the ice-covered period into 3 stages: freezing period, stable period, and the melting period. Another reason about the 3 periods I will discuss in the next. The evidence of phytoplankton in water ranged about 422 to 8 x10 to the 4th per milliliters, and in the ice ranged from about 1.2 and 2.3 to 10 to the 3rd per milliliters. In addition, it also found that both in ice and water, in the vertical direction, the number of phytoplankton is evenly distributed. We also found that in the vocational, in the vertical direction, the salinity and the water temperature of the lake are uniform, except for the surface water, which is affected by the ice, which can also prove that the vertical in the vertical distribution, the lake is uniform. In order to explore the distribution of phytoplankton during the whole ice covered, we also collected a total of 11 sampling points in the lake. The sampling points are shown in figure 17, and the results of phytoplankton evidence were shown in figure 17b. We found that all sites in the lake were similar. The biomass of phytoplankton was similar. It can be said that the phytoplankton are fairly evenly distributed in the lake. So we choose one of them, the point 1, to put the floating platform. And the sensor was on the platform all the whole ice covered period. Next is the phytoplankton community structure. There are a total of 40 species of phytoplankton in 6 phyla. Also, we can see evolution, how to say, secession, a clear secession in the ice-covered period on the phytoplankton community structure from the chlorophyter and bacillar phyter to chlorophyter to bacillar and phyllorophyter. In the ice, there also a secession, and also the secession period is consistent with the melting period or stable period and freezing period. So we discuss the factors and the environment and the phytoplankton structure from the 3 ice-covered period. The results of applicants' technology were consistent with microscope counting. We also compared the changes of dominant algae species of phytoplankton in different periods. And we found that the ice-covered period, during the ice-covered period, Hanzhang Lake was a media polluted lake and a media traffic lake. Another interesting result is the Gynodidium is located in the upper media layer of the ice and it produces toxins. The last part is the environmental factors affecting the phytoplankton community. We found that the changes of phytoplankton species are related to the radiation, photosynthetically active radiation, and the surface water temperature. Also, the relationship between the primary productivity and the environmental factors showed that the surface water temperature and the radiation is related to the primary productivity. The productivity and the chlorophyll A decreased significantly during the melting period. To summarize my presentation, there are 3 conclusions. The first one is during the ice-covered period, the biomass of phytoplankton was at a moderate eutrophication level in the lake near Liaodong Bay, in the Hanzhang Lake near Liaodong Bay of Bohai Sea. Dominant secession of phytoplankton community exists under the sea, under the ice. The last one is the changes of phytoplankton species are related to their surface water temperature and their photosynthetically active radiation. Okay, that's all. Thank you for your attention, and any questions is welcome. Thank you.
Содержательный рассказ.
Thank you so much for your presentation. Dear colleagues, do you have any questions? I have a question. So you mentioned that in some cases you managed to determine that the could you please tell us what was the criteria for the determination of the lake? How dirty is the lake? How did you manage to get this information? How polluted is the lake? Yes. How could you measure it?
The phytoplankton and the nutrients. Yes. How to detect this is we detect the phytoplankton from
Нет, по
the
какому параметру вы определяете, что это загрязнение, ну, какая степень загрязнения?
What was the parameter to determine how hard is this pollution in the lake? What was the criteria? You said you had a medium pollution. What is the criteria?
The medium pollution from the nutrients in the lake, including nitrogen and the phosphate here, and chlorophyll to analyze the pollution of the lake.
Понятно, не по фитопланктону. Понял, спасибо.
You mean it wasn't the phytoplankton that you measured in the lake, yes? So you managed these components. Okay, thank you. So moving on to the next presenter, Elena Gogina. Are you ready? Yes, I am ready.
Коллеги, добрый день. Hello, my name is.
Good afternoon, dear colleagues.
State University for Geological Prospecting. Then we have translation now. I will speak Russian, and you can see my report. Итак, коллеги, я бы хотела.
So, dear colleagues, I would like to talk a little bit about issues of wastewater treatment and to talk a bit about the quality of wastewater that is being discharged into water reservoirs. And this is a very topical issue, pressing issue, especially in northern regions. And this is what I'm going to be talking about. And I'm going to start that in June 2022 in our country, the State Council was held, headed by the President of the Russian Federation, which was dedicated to engineering systems, including engineering systems connected with water supply and water discharge and sanitation. And the issues were identified that are being put forward today by environmental scientists. And you can see on this slide that the wear and tear of networks is over 40%. And the quality of wastewater, which is discharged into water, is only in 20% of cases conforms to the norms and standards. And this issue needs to be resolved, and we are working in our university on this issue with our partners. And today I would like to talk about the issues that exist today and which we're working on. So the reason for this low quality of water treatment is the fact that most of the water treatment plants in Russia were built before the 1990s. That is, at present, they are very old, and the number of organic compounds to phosphorus and it's very low. and it differs a lot from the region, depending on the region of the Russian Federation. The modernization of these water treatment plants requires lots of investment, and it is not being done as required. And modern technologies right now are not being used depending on the specific conditions that are there in regions. So what are the issues that are there? You can see it on this slide. So the main issues is the determination of the capacity of treatment facilities, because there are quite a lot of different requirements and legal requirements, and then how to define wastewater treatment technologies that will be working in various regions, including northern regions, how to operate these water treatment facilities, especially in the Arctic, and who is going to pay this and how much it's going to cost. So concerning the determination of the capacity of treatment facilities, we have we are at the stage which we expected to be at, and we are looking at the population now, the industrial enterprises in the area, and the state of repair of sewer networks, and the volumes of water treatment that is being taken by water treatment facilities has been overestimated every day. So, for example, we declare about 10,000 cubic meters of water, but in fact, only 5,000 cubic meters are being taken in, and this lowers the quality of water treatment. It doesn't improve it. What about the technology of water treatment? And we have this decree of the government, which defines the technologies that are to be used in Russian Federation. Of course, we need to use the existing infrastructure. And when we talk about the shift villages and maybe like tourist villages, it is possible that we need to have a kind of different ways for them to work. For example, the load changes of these wastewater facilities, because when there are many tourists in one season, for example, the treatment facilities are under heavy load, and when there are no tourists, there are not enough load. And as such, what solutions do we have? So the first one is an integrated approach. It is the reconstruction of the entire water treatment network, not just partially. Second is the use of new modern technologies, considering local conditions, using technologies that were designed specifically for the Russian Federation, and including the northern regions of Russian Federation. And of course, we are also looking at regulative requirements. So what do we need to choose? What kind of equipment do we need to choose?
Елена Сергеевна, вы нас слушаете, да?
Елена Сергеевна, are you online? So it seems we have technical issues. So is it from our side or the other side?
Елена Сергеевна, мы вас не слышим, презентация не видно.
Elena Sergeyevna, we can't hear you. Yes, I have some communication issues. Can you hear me now? We can't see your presentation, but we can hear you. So probably there are some issues. So I'm going to conclude my report. So what do we need to... What about the choice of the water treatment facilities? You have seen in the last slide that there are container type water treatment. Of course, they're not going to be working in northern conditions. And I want to say to local authorities, do not acquire these container type water treatment facilities. You need to build specific water treatment facilities inside buildings which need to be heated in northern regions. And there was the issue of operation of these facilities, the level of the automatization and the level of smart technologies today is quite good at the moment. And we talk about the fact that today during the reconstruction, during reconstruction, we need to use the so-called smart digital technologies. And a model is being prepared before the reconstruction connected with the automation and operation of these facilities. And this is going to lead to automatic functioning of these water treatment plants. Our modern technologies allow for this quite easily. And concerning the cost of this, we now understand that any technology today costs money. If we talk about northern regions, there is also the cost for heating water, that is electricity expenses. And talking about designing the reconstruction of water treatment plants in northern regions, we need to pay special attention to the costs that the population will have to pay, the tariffs, monthly payments. So if you build an extremely expensive water treatment plant, then of course the cost for the population is going to be very high. And this is the end of my report. And I want to ask all of you, our colleagues, to be considerate to the environment. And I wish everyone a success in your work and in the work of this conference. Thank you. Thank you very much, Elena Sergeyevna. Do you have any questions? I have a question. So you talk about container water treatment plants, heated ones. Is there any positive experience of using such type of water treatment plants? No, I wanted to say I have quite a lot of experience, and we are working with colleagues in Novosibirsk University, and we are saying that container water treatment plants in northern regions work very bad. There are many of those, they just freeze down, even though they're being heated. They're not energy efficient at all. And that is why I want to say, do not use this container type water treatment plants, but design and construct standard water treatment facilities. Thank you very much. Thank you. So our next speaker is Ruslan Gradnichev, Head Biological Monitoring Laboratory, Ammosov, Northeastern Federal University. Lake ecosystems of Yakutia, specifics, economic significance, protection.
Добрый день, уважаемые коллеги. Моя
Good
презентация.
afternoon, dear colleagues. So my presentation is on lake ecosystems of Yakutia, features, economic meaning, and protection. As you all know, Yakutia is the biggest region of Russia. The area of Yakutia is more than 3 million kilometers, and we have more than 700,000 lakes in Yakutia, which are in their size are at least 400 meters. As for the nature and climate conditions, you all know that we have a very harsh winter with temperatures lower than 60 degrees in winter, and we have very short and hot summer. The whole territory of Yakutia is on permafrost, the thickness of which can reach more than 1 kilometers in depth. So this all led us to different lakes. And in Yakutia, we have a regional classification of lakes developed by Innokenty Zhirkov. And based on this classification, all the lakes on their genesis can be of different type. And the most widespread types of lakes are thermokarst lakes, erosion thermokarst lakes, and fluvial erosion lakes. In general, for all Yakutian lakes are not very deep, not very large. They have fresh water. It has a bit high pH conditions, pH conditions. All the lakes have a big meaning for citizens of Yakutia. For example, the lakes are actively used by local people to get fresh water. Despite the fact that in the Republic we have many rivers, it is very traditional, however, to use lakes for drinking and to use lakes ice for drinking. And here on your slides, you can see local people getting ice, lake ice for drinking. They melt it and then they drink it. Another important way to use lake ecosystems is using so-called alas or areas around the lake. These areas are used for grass cutting, for agriculture, for cattle, food, and one of the main activities for Yakutian people is fishing. You can see the traditional Yakut fishing on the screen. It's called monkha, and the main fish is karas, the carp. It is very rich in fish oil. And people in late autumn, they gather all together on the lake and fish. Another important aspect to use lakes is to hold different social events during the ice period. Lakes have flat surface, and it is a very good place to hold different events such as Day of Water. And sometimes they built ice skating rinks on the lakes. For example, the Tallow Lake in the center of Yakutsk. This is a traditional ice skating ring in the center of the city, which is very popular among local people. Another main activity of lakes is using lakes as a source for health and for the well-being. For example, in Megino-Kangalaski district, there is the famous Abalach Lake, which is rich in sulfide dirt, which can be used for medicine aims. We have good points about the lakes. However, we also have some ecological problems related to the lakes, such as eutrophication. The lakes are not very large in size. That's why if the lake is in the town or in the settlement, they always eutrophiate. So these are the pictures of Yakutsk lakes, which situation that happens in the cities mostly. Another big problem is garbage in the lakes. You also can see some photographs from Yakutsk city. You can see that the garbage is on the lake shore, coastal area of the lake. Also, the garbage is in the lakes, which is also a very big problem for water areas of settlements. Another problem is water pollution of lakes with chemical pollutants. You can see the most popular pollutants of lakes, of city lakes, such as oil products, phenols, heavy metals can also be one of the pollutants of lakes in Yakutsk. Apart from anthropogenic pollution, the lakes can be harmed by natural pollution as well. For example, lakes in the Arctic and in the subarctic, they you can see the diagrams on my slide. Almost 17% of the lakes in the Arctic are medium polluted. Another problem that I'd like to address is destruction of the flowing lake system. In Yakutsk, we had such accident which led to eutrophication of the lake and its chemical pollution. So what are the solutions to these problems? We have conducted several experiments. So the government of Yakutia has created a net of the natural protected areas. So you can see its map on your screens. Currently, there are 238 protected areas in the Republic. And amongst them, we have also so-called a list of the unique lakes that are included into this total list. You can see them on your screens. So these are unique lakes of the Republic, which are being protected. Another solution is reconstruction of the water channel in Yakutsk. Since 2017, the water channel started to reconstruct. And another solution is cleaning lakes. We clean our lakes from eutrophication when it's on its peak, and also local citizens, they also clean the shore of the lake from garbage. So that's it. Thank you very much for your attention. Dear colleagues, do you have questions? Tell me, please. So you've mentioned the pollution of the lakes, that you have oil products in the lakes. So what are these oil pollutions? Are they on the surface of the lake, or are they somewhere deep down in the lake? You could see them on the screen. We have that would be the oil products in the lake because of the sewage. Why I ask is that in our Tomsk State University, we have a very unique product that is being used everywhere. This is cleaning water areas from oil, because in some lakes, in some areas, there are more than there are like layers of oil which are 1 meter in their thickness, so we can clean them using our product. And I hope that you don't have such cases in Yakutsk. So thank you very much. So we are moving on to our next speaker, Nechiparenko Grigory, Far Eastern Federal University, with his report on studying ice hummocks for safe development of power industry in the North and the Arctic. Please.
Григорий Юрьевич, на связи, да?
Grigory Yurievich, are you here? Okay, so let us check. Maybe there are some other speakers who we missed. Professor Lee Jin-soon, Dalan Technical University. Do you hear us? Okay, I think no, we don't have him. What about Shao Keke, Beijing Polytechnical University? We also don't have this speaker. So I think this is it. So thank you for your presentation. It was very interesting to go through all the presentations, and I would like to say that all the presentations, all the reports will be saved, and maybe we will be able to share them later after the event. I hope that you all enjoyed our section. You managed to learn about each other's projects and researches, share your opinions, and I hope that all the participants, we should combine our efforts to promote joint Russian-Chinese cooperation in terms of studying Arctic ecosystem. Thank you, everyone. Thank you for joining us today. And thank you to the participants who managed to come to Yakutsk physically from other cities of Russia. So this is the end of our section. Thank you, everyone.
Thank you all for coming to our conference. Where we have a lot of new information to share with you all. Let's begin this section. Please, Rus-sian, please.
Hello, dear colleagues. Good evening to Yakutsk and to Harbin. With respect to all participants, I'll try to make my report in English, but in complex cases, I could switch into Russian, but hope we could sort out it by ourselves, and our organizing team could have some rest with translation. My name is Kirill Lushan. I'm from Moscow Polytechnic University, and we have some research results and some experience that I want to share with you today. The first point is that regions with severe climate possess significant requirements and restrictions on the thermal capacity of heat sources. In such complex conditions, it is important to ensure permanent and uninterrupted supply of all types of resources, and of course, economic feasibility of such design of our decisions. The severity of the climate is estimated by non-physical value, heating degree days. This value make possible to estimate not only installed capacity of heat sources, but also the total energy consumption for the whole winter season. According to this value, you can see it on this image. Moscow is the coldest from all big cities, and at the same time, the biggest among coldest one. And to say the truth, it's equal for Europe and the world. Maybe it is Moscow. It is the coldest big city in the world, and the biggest from coldest at once. So the Moscow-based skills and experience in heat supply is unique, and I think very valuable. Yes, I know about Yakutsk. Yakutsk is unique case too. It's extremely severe climate region, but Moscow is much more bigger, so the experience very valuable too for Moscow and for Yakutsk, of course. Severe climate is not about only winter. The sharply continental climate is characterized not only by cold winter, but also by hot summer. And in summer, we meet the issue of cooling loads. Cooling is always more complex and much more expensive thing. Much more expensive process. The cost of cooling capacity unit is 10 times higher than the cost of the same quantities of heat. Here on this image, our approach to estimate annual energy consumption through the heating degree days in application for both winter and summer. This paper is published 2 years ago, so it is available by this link. So, what points do we meet in this field? The first one is thermal insulation problem. The next, the similar, exposed and unprotected surfaces, hot surfaces, a lot ones. Then we have the problem of deregulation, high temperature and high coolant flow. The next one is energy losses with warm exhaust air. And then high consumption of pure water and significant energy cost for water boiling. I need your attention on this image because here some kind of surprise for customers and even for some experts, then almost high value of heat consumption is not hidden here. Hidden is on the left, here and here, but then the highest value is not hidden. It's hot domestic water heat energy consumption. It's here. So the main problem for energy efficiency still not hidden, but domestic hot water and ventilation. Heating of supply air, it's here. It's the third one value. This data is presented before by Professor Vladimir Gagarin from Moscow. By the way, the next problem, it's not obvious and not often discussed, but a dry windy climate is characterized by significant consumption of water to humidify the supply air in air handling units and air conditioned units. Here is the estimated amount of this water. And then we have a number of other issues. For example, the next one is rising outdoor CO2 concentration that leads to increasing supply ventilation rates. And if ventilation rates are rising, we increasing the energy consumption. And as a result, we need more frequent filters replacing, and we need higher filters resistance. So it's the issue for energy efficiency too, but not obvious for everyone and absolutely not obvious for customers. It's only for experts. The next is maybe finally low perception index of this problem. Customers are not aware about all points I presented here. And here, the place of Russia in the environment perception, energy perception index, it's not high. It's a highly developed country with low perception index of this problem. I think it should be noticed. And what should we do here? Just some steps. I think at first one is stop over-insulating. There are no reason to over-insulate because heating and energy losses through the building envelope is not the primary problem for energy efficiency and not the primary problem for energy supply in severe conditions. The next point is type of habitation. If we live with high density, we have no need to reach the similar levels of heat resistance of building envelope. When in Europe you need to have 10 points, in Russia for the same purposes, for reaching the same results, the same outcomes, you need only 1.5 for the same energy efficiency results. The next issue is quality of construction. Even if you have higher demands in regulation, you should be ready to provide it in real construction. Here is the results of research made here in Moscow by Dr. Kryshov. He says that most of new most of new buildings are not satisfy the regulations, not satisfy the limits for energy efficiency. And then, of course, some smart things, reducing the range of heat generation units, using renewable energy, decreasing the coolant heat agent or increasing the coolant in some temperature. New types of equipment, of course, this is the way to reach purposes in energy efficiency and providing indoor air quality in severe climate regions. Of course, heat recovery everywhere, for water, for air, lean processes everywhere. We should save any resources. And finally, 2 steps. This deals with averaging heat loads and making more complex heat sources that even leads to decreasing capital expenses for heat sources. And the final one is most complex way, but most innovative way, is using harmonic decomposition for data of energy consumption and making the building characteristic for prediction driven heat sources automation. So I appreciate your attention today, and thank you very much for inviting to this conference. Thank you, colleagues.
Thank you very much. And another is Antomer Napzia. Okay. The Oracle editor. The Anna Krupiakova. Okay, thank you.
Hi, everyone. Give me just a second. Okay. Have you see my screen? Everything is okay?
Okay, it's all right.
I guess I have some technical problems with my Zoom demonstration, but I hope it will be fixed. Okay. Hi, everyone. My name is Anna Korobeynikova, and I want to introduce you my issue. Just a second, technical problems. Okay. Okay. I think right now everything is okay.
Maybe something wrong. Don't worry.
I think I have problems with my Zoom demonstration. It's not my first time with these problems. Give me just a second, please. Okay.
It's quite good now.
Okay. Okay. Without full screen. Really sorry about it. Okay, I want to introduce you my issue, features of the formation of variation.
We've lost connect with Anna. I think it's some technical problem.
Yes, the bad signal causes these problems. Maybe we can do another Oregon.
I think better to replace Anna and then give her a chance on another step.
Yes. Maybe we and another professor. Yeah. Oregon Sogovicha. Okay. Oregon Sogovicha, Professor Sogovicha. Yes. Thank you.
Уважаемые участники форума, хотел бы вам представить свой доклад.
Dear participants, I would like to present to you my report on the topic of development of asphalt concrete pavements used in the geopermafrost zone. So what are the existing problems of destruction of road surface? The first problem is destruction of the road coverage due to the track bounded on the upper layer, and then it moves to lower layers. The second reason of deterioration is formation of cracks in the asphalt concrete pavement and penetration of surface water with washing out of small particles of the unreinforced pavement. And the third reason is decrease or deformation of the subgrade and the cover of the road. At the present time in our country, there was an adoption of a decree of the government dated May 30, 2017 on the standards of financial costs and rules of calculating the amount of budgetary appropriations for for overall repair and maintenance of highways of federal significance. The overall life of roads has increased from 12 years to 24 years after the previous overhaul. Accordingly, in order to improve the quality when adopting projects and other technologies and building materials, we need to apply effective designs. So the purposes and objectives of our project are development of an effective composition of asphalt concrete mixtures to increase the durability, which can be during the period between the repairs and the conditions of the far north. So we need to meet the following objectives. First of all, to study the region where we're going to design the areas and the streets. We need to study the physical characteristics of the materials. We need to select the composition of asphalt concrete mixtures according to the purpose of laying on lower and upper layers of the coating, and we need to determine the physical and mechanical characteristics of samples of asphalt concrete meat. As for the construction area of highway and city streets with asphalt concrete layers, we can use it in the territories with high traffic intensity. That would be in the central part of Yakutia. There we see that the traffic is very intense, especially in the city of Yakutsk and near areas. And on the cover of the road, we see that there are cracks forming, and the sublayer is the sublayer deteriorates as well. That's why we need to improve the materials. Next, we can see the materials that we suggest to use in the harsh winter conditions for roads with high traffic in Yakutia. First of all, we need to use crushed stones and from extrusive rocks. So we need to mine the materials in Aldan region. There is a place where we can mine it in Aldan region, and there is a certificate for mining. So the name is Aldan. The abrasion grade, the breakability of crust stone is M1200. Abrasion grade is I1, and frost resistance of crust stones is F200. Next, we need to use mineral powder for asphalt pavement. It can be used to form an asphalt concrete binder to increase the strength of the asphalt concrete mixture and to increase the bituminous layer. When we use crushed stones from extrusive rocks, we need to use a special mineral powder, because when we use a different type of powder, so in Yakutia, we don't have a production of mineral powder. So we need to create such production in Yakutia. We have places to produce other materials. However, they are not relevant for our research. Next, as for the bitumens for asphalt mix, we import them from other regions of Yakutia. Usually we use oil-based, which is obtained by oxidizing the residuants of atmospheric vacuum distillation of oil and the selective separation of oil products used for the preparation of asphalt concrete mixtures and organic mineral mixtures. We should also use some modified bitumen, which will be modified using special substances. It can be used to increase the durability and reliability of road surface. The modified bitumen has a number of high performance characteristics compared to the original bitumen. So it is very well performing in lower temperatures. Next, to reach our goals, we worked with the students. We have completed the work on a comparative analysis of the use of granite and limestone rubble. The results are presented here. So when using granite, the characteristics of durability increased by 18%. And according to temperatures lower than 50 degrees, when we use limestone particles, lime rock particles are higher. The performance of lime rock particles are higher when using the granite. In order for asphalt pavements to withstand the overhaul period, it is necessary to apply a crushed stone and sand of high strength. We need to use bitumen with high elasticity and low brittle temperature. We need to, or maybe it's recommended to use the device of the basis with a hard surface from asphalt, concrete, or black gravel, and it is necessary to build a subgrade from soils that are not subject to subsidence. Currently, we're working on developing effective mineral materials and modified bitumen suitable for low temperatures. Thank you for your attention.
Thank you very much.
If you have any questions.
Next professor is Anna Ivikarina.
Hey everyone, one more time. Okay. I want to introduce my issue, features of the formation of aeration of comfort of residential buildings on the slope territories of settlements of the Arctic zone of Russian Federation. And first of all, I want to say about problem. The relevance of the study is due to the fact that the most settlements of Russian Arctic are located on the slope territories and have residential areas on the slopes in reserve. And the development of the cities of the Russian Arctic, according to our important resolution number 484, this is a strategically important task for the Russian Federation. And however, the techniques of planning residential areas of urban development, as well as its external and internal landscaping designed for flat terrain, cannot be applied without reducing the quality of the urban environment. The quality of the living space is formed from many factors, and one of them is the aeration regime of the territory. However, there are no uniform comfortable values of wind speed for any development, since the wind regime is wind condition occurring in a certain territory, which means that different territories with their landscape and climatic characteristics have their own characteristics of the formation of the aeration. Aeration regime of one territory may differ significantly from another. And since the territory of the Russian Arctic is characterized by difficult climate conditions, low temperatures, high wind speed, and a complex landscape, determination of the aeration regime of such territories requires special attention and consideration of all features, in particular change in temperature and aeration regimes, which affects the quality of the living environment. And based on the analysis of the existing domestics and international experience, the following features are identified by me that affect the formation of the aeration regime on the slope territories of the Russian Arctic. And you can see it on the slide. And first feature is the harsh cold climate of the Arctic zone of the Russian Federation, low temperatures, and then the next one feature, a significant part of the territory of the Arctic zone of the Russian Federation has complex geomorphological conditions, and a lot of territories located on the slopes where the wind flow transformation, and a lot of different deformations of wind flow, for example, flow separation, turbulence, dynamic updrafts, and others, which determine the specific nature of the aeration regime of residential development on the slopes. And the last one feature is development of settlements in the Arctic zone of the Russian Federation. The use of special planning solution and additional means of improvement is required to ensure comfortable living conditions for the population in residential areas on the sloping territories of Russian Arctic. I made huge GIS analysis, and based on this analysis of the settlement of the Russian Arctic, with the help of the quantum GIS software package, as well as the analysis of existing domestics and international experience, the features influencing the formation of the aeration regime in the sloping territories of the Russian Arctic, given in the form of groups of factors, geomorphological, aeration, and urban planning. The developed system of parameters for assessing factors determines the order of formation of the aeration regime in residential areas on the slope territories of the Russian Arctic. At this slide here, you can see the relief of Arctic zone with the help of quantum GIS. The ratio of slope territories to plains was calculated, as well as for residential areas on the slope in relation to residential areas on plains. You can see it diagrams. Here you can see aeration factors analysis. You can see analysis of aeration parameters of slope territories in residential development of the Arctic zone of the Russian Federation. Their temperature, wind speed, and prevailing wind direction in the most discomfortable period. And here you can see that just 4 meters per second is discomfortable wind speed for Arctic zones settlement. This analysis was made according to Ratner's issues. And here you can see urban planning factor. Residential building in the sloping territories of Arctic zone of the Russian Federation was considered for the assessment of urban planning parameters, and 3 typical urban planning solutions were identified for my research, as well as average indicators of density, average density, and average number of floors of building average by the results of the study of building on the slopes of the SRF. And here you can see 3 morphotypes: and ribbon, perimeter, and sporadic. And for the convenience of determining the aeration comfort of residential buildings, I developed a theoretical model of the aeration regime of residential development of the sloping territories of Arctic zone, and you can see this model on the slide. The theoretical model has 3 levels. First one, residential area, second one, build-up area, and the third one, courtyard area. And each level has certain parameters. First one, residential area, 1, 2, 3 aeration factors, and urban planning, geomorphological factors. Level 2, build-up area, planning factors, urban planning factors, and level 3 courtyard. Here you can see optimization parameter OK attained in the process of simulating level 1 and level 2 parameters, and parameter Y, area of discomfortable zones. And the main urban planning task is the process of reducing the proportion of uncomfortable zones in the yard space. And here you can see a methodology of modeling aviation regime of residential development in the sloping areas of the Arctic zone of Russian Federation, developed by me. And the main issue, the main task of my issue was made modeling of aviation regime, and I used ANSYS Fluent software package and ANSYS workbench calculation platform. This software were used to conduct a theoretical study using mathematical modeling. And mathematical modeling was carried out for 4 slope exposures and 6 different slope height gradients for each of the 3 previously defined morphotypes. Total 72 cases for modeling. And here you can see a result of my modeling for 3 different types of slopes, and etc. And to calculate the proportions of uncomfortable zones, the main optimization parameter K, I use the script which I developed in Excel, and you can see the script here. And as a result of modeling, the following results were obtained for the perimeter morphotype of the building, the slope with an eastern exposure and a slope of 96% is the most uncomfortable, for example. And you can see results for 2 another morphotypes at this slide. You can see percent of discomfortable area and type of slope. And based on the data obtained, a scale was developed to assess the comfort of residential development based on the analysis of the aviation regime to determine the gradation of the scale, and analysis of velocity as a fields obtained, and the nature of the flow distribution in the yard area of all morphotypes was carried out. You can see this graduation on this slide and description. And as a recommendation, a methodology has been developed for assessing the proportion of uncomfortable residential development zones in the sloping territories of Russian Arctic. And it consists of 3 stages. First stage is the collection of initial data. The second stage is assessment of exposure and morphotype of the building using a table of dependencies of the slope and morphotypes of the building and petal diagrams of the distribution of the proportion of uncomfortable zones. And the third stage is the selection of landscaping techniques using the windproof measures in order to reduce the proportion of uncomfortable zones to at least 25%. You can see it on this gradual scale. This is comfortable. And the results obtained can be used by urban planners for the development of settlements of the Russian Arctic. The dependency table and navigators allow you to determine for a specific slope and exposure the morphotype with the smallest proportion of uncomfortable zones. Specialists can also use the methodology for assessing the proportion of uncomfortable residential development zones in the sloping territories of Russian Arctic for the development of complex territories of Arctic cities. The results obtained can be used in the development of territory planning project in Arctic settlements, as well as in the development of documents on the planning of territories of residential areas of settlements in the Arctic zones of the Russian Federation. Thank you for your attention. If you want to ask me something on English or maybe on Russian, welcome. Thank you very much.
Any questions? If no questions, the next professor is Igor Gavricha Slebodycheva. Please. Maybe another professor, Ilya Vladimirovich Denikovy. And another professor, Alexander Leonidovich. And another professor, Anton Mikhalovich.
Сейчас меня слышно? Да, все, отлично.
Okay.
Меня зовут
Okay,
Попов
can you
Александр.
hear me now? I am Alexander Popov from the Engineering Technical Institute of Northeastern Federal University, and I study the peculiarities of hydration and frost resistance of cement with natural zeolite additive.
В чем суть? На сегодня, получается, в Арктике
As for today, in the Arctic and in the north, we do not use a whole range of different research connected to composition binders. I think it is connected to the fact that existing composition binders, they become full in a different way than cement or concrete materials. Such a way, this is a different compared to regular cement, and it takes more time than usual. And in the north, we have a very short period of building because when the temperature is below zero, the conditions of cement, the water does not combine with cement, and the curing does not occur. So as we look at the so we want to study how can we use other materials. So why do we decided to use natural zeolite? In Yakutia, we don't have many components that are active as an additive. We know that natural zeolite has a very low pouring and has very good specific characteristics for absorption. It has very high absorption properties. And we have studied all the literature There has been a lot of different research where natural zeolite was used as a natural additive in cements, not only to replace some materials, but also to increase the durability of concrete. In Yakutia, we have natural zeolite called khangurin, can be found in Suntar region. Now it is used only as an additive. We have studied this natural zeolite through X-ray RFA analysis and under a microscope as well, and we found out that there are such components as crystallite, halidite, quartz, and we found some crystals of hallandite as well. And our literature study helped us a lot. You can see pictures on your left. These are some tabular crystals with perfect cleavage layered aggregated. As for, you know that we do not use natural zeolite in components as well. It is not used full. We need to first blend it, cut it, grind it. We can see that in our lab, we have spent 2 minutes grinding it. And if we compare it to other mineral components, sand, for example, we see that the grinding occurs twice or 3 or even 4 times faster compared to grinding of other natural sands found in Yakutia. So it is very easy to grind it. So why is it so? I think it is connected to the fact that the zeolite has a poly mineral content, and there are such components as cristobalite and quartz, and that's why the grinding is faster, which can be proved by other research. Some other researchers also claim that our zeolite material can be used as a grinder for bigger components. For example, we can use it to grind quartz. Thus, it will happen faster. Then we had to, apart grinding and looking at the components and looking at it under a microscope, we also studied determination of activity in relation to calcium oxygen cementum. We have conducted 2 experiments where we determined the qualities of this component, and as we can see, the natural zeolite has more active materials, and as the coefficient of equality, we have used the amount of absorbed cement, and we found that it is more active and can be used as an additive. So our further work was related to studying our additive as a additive for cement to determine how it affects the frost durability. So first of all, we have compiled the ultrasonic method to study the strength of the component. Oh, I forgot to mention that to study how durable is concrete under lower temperatures, we used ultrasonic method. That is to lower the amount of examples that we can use. So the first component, we have used several cements, which had a 10, 20, and 30% of ground natural zeolite in it. We made examples in squares, in cubes. We could use them to study the durability and transparency. So we found a correlation between the ultrasonic transparency, and I didn't include the formulas that we used. So we had a linear coefficients. We didn't use many examples, so we think that linear approximation is not the best way. However, we decided not to go into other options. So further on, we decided to freeze our materials. We had for 24 hours, there was a pre-saturation period. Then we started freezing them according to the regime you can see on your screen. So the results of the experiment during the ultrasonic method, we found that after the first cycle of freeze-thaw, the material lost its durability, that the speed of ultrasonic became faster. But when we added the natural zeolite, after the first cycle, the durability increased. But when the concentration of natural zeolite increased more, we have decided that after the third cycle of freeze thawing, the durability even increased, and only after that it started decreasing. So that proves that natural zeolite zeolite helps for post-somatic activity, it increases it. So the data was approximated to determine the breaking point on frost durability, and according to the approximation conducted, when the natural zeolite was at 30 or 50%, the amount of cycles of freezing and thawing could increase. So we see that when we add natural zeolite, the frost durability increased. And I think that was the end of our experiment. We reached our goals. And for now, we recommend to use natural zeolite as an additive to increase frost resistance in cement. That is the end of my presentation.
Okay, thank you. Next, Professor is Sego Monatina Mochianova. Yes, please.
Good afternoon. Sorry, Professor, I'm waiting for myself. I'm Sergey Molchanov, so I'm waiting for me. May I start right now or should I wait?
I think you can start.
Okay, thank you. Can you see my presentation right now?
Yes, everything is okay.
Okay. Good afternoon, dear colleagues. My name is Sergey Molchanov. I'm the student of Magistracy of Moscow Architectural Institute, and my topic is the development program for autonomous urban complex on Spitsbergen. Archipelago Spitsbergen is the only... Sorry for that, my computer. Archipelago Spitsbergen is the only place on the planet which goes into another country and has our settlements. Initially, there were 3 settlements called Barentsburg, Grumman, and Pyramid. You can see them on the map marked with the red stars. Before the Second World War, Grumman was closed. After the collapse of USSR, Pyramid was conserved. Therefore, the development of the last and strategically important for our country's settlement, Barentsburg, is the key point now. Barentsburg is the second largest settlement on the archipelago. The population is approximately 500 people. On the map, you can see the biggest bay of archipelago is Fjord. Barentsburg is located at the very beginning of the bay, so the strategical location is pretty good. The main economical activity before 2006 is the coal mining by the company Arc-tic coal. After 2007, the situation became changed. The main problems are recreation, living and production areas are fully intersect each other. Economical and social failures increase the discomfort of the place. Barentsburg is uncomfortable. Its high-standing separately buildings in Soviet style looks scattered. The settlement places on the slope and very windy. The opportunities are Hammer and Russian Scientific Center. The risks are demographic imbalance and economy. The small map is the 3D panoramic view of Green Bay in which Barentsburg is located. The risk coordinate is the settlement of itself. The big map shows different functional zones of Barentsburg, where the red line is the border of the settlement, blue one water area, brown road network, and black the landscape. All functional zones are split into 5 main parts. Yellow for residential area, orange for business and public areas, red one for agriculture, violet for engineering infrastructure, and black one for industry. Hypothesis. To create the autonomous urban complex in Barentsburg with the following components: ecological program, functional program, life support program, and social program. According to Professor Krashemennikov, the first component, ecology, is fauna and flora plus solar and wind energy. We should very carefully protect the rare flora of Arctic and its absolutely unique fauna. The alternative energy resources are inexhaustible. Therefore, the transformation into production is the on-table technical solution. The realization of such projects becomes more complicated due to the climate conditions and absence of the proper experience. The introduction of such stations is completely safety for Arctic nature, which is a very important advantage of the technology. Solar and wind energy using is the highly interesting tendency around the world. For example, on the upper photo, you can see the station in Yamal, which was opened in 2017 and consists from 2 wind generators, 30 solar panels, and accumulator. The highest advantage is full environmental friendliness and absence of any influence onto nature. The electricity produces to the solar energy and wind only, i.e. using renewable and inexhaustible resources. In case of the fog, the station uses the reserve energy accumulated in batteries. Another example can be seen on the lower photo. It is EU Scientific Polar Research Station, Princess Elizabeth in Antarctica, the first polar base that combines eco-friendly materials, clean and efficient energy use, optimization of the station's energy consumption, and clever waste management techniques. We should remember that the Earth is not our planet only. All living creatures shared it in the same ratio. All of them except human beings care about the planet. Arctic is still in the beginning of the development. Depends on us only which way to use. So the first component, ecology, could be reached by attention to fauna and flora together with the solar and wind energy using. The second component, economy, is logistic plus storage plus workplaces. The opportunities in Arctic workplaces could be found in administration, trading and service, production, culture, education and science, and tourism. Fully electrical snowmobiles for winter with a separate station, and modern water station or port with a jet ski and boats for summer are the ways to improve logistics. It is highly important to keep goods in a proper condition. For example, on the photo you can see the exhibition center for Arctic Global Archive in Longyear. The visitors could explore the Arctic Archive and seed vault collections. The seed vault provides long-term storage of duplicates of seeds conserved in genobanks around the world. This provides security of the world's food supply against the loss of seeds in genobanks due to mismanagement, accident, equipment failures, funding cuts, war, sabotage, disease, and natural disasters. For any settlement, it is highly important to be economically developed. Thus, the second component, economy, can be improved by attention to logistics, storage, and workplaces. The third component, livability and nature, is farm vegetables and water plus garbage. Do we manage to grow food in Arctic? What fruits, vegetables can we grow? Is it possible to farm in Arctic? Yes, we do. Cucumbers, different greens, onion, pepper, radish, and tomatoes grow in Barentsburg in special prepared warm greenhouses. Moreover, there is a pig farm there. On this photo, you can see Ammosov, which is a combined heat and power waste-to-energy plant and recreational facility in Scandinavia. The recreational components of the facility are the dry ski run, hiking trail, and climbing wall. The most important in Arctic is to create the autonomous system, which should be functional, not very expensive, reliable, and simple in use. Only the latest technology could solve geological and anthropogenic problems. So the third component, livability and nature, could be reached by using local farm vegetables and water with the garbage utilization. The last but not the least component is social, which is education plus fitness plus leisure plus medicine. On the upper photo, you can see the University Center in Longyear, which is a state-owned limited company that is involved in research and provides some university-level education in Arctic studies. The courses offered fall into 5 main science disciplines: Arctic biology, Arctic geology, Arctic geophysics, Arctic safety, and Arctic technology. Helicopter is the quickest and most important medicine transport for Arctic. The human being can survive in ice water for just 15 minutes, unfortunately. To care about the health is not less important as to care about the nature. Healthy spirit is in a healthy body. Even Arctic can suggest some absolutely unique entertainments, swimming in the ice water, for example. The population in Arctic settlements is much lower than on the mainland. To keep the healthy atmosphere in any society is highly important and much more difficult. Education, fitness, and leisure will solve the problem and protect the close team. Medicine will help in case of the emergency. All of them together form the last, fourth social component. Arctic Trefoil is the military base for 150 people on Franz Joseph Archipelago. The total area is 14,000 meters squared. Constructed from the light precast metal frame, which maximum simplifies the process of assembling, extremely important for the region. It's based on the pile foundation for protection of the permafrost. So all 4 components mentioned above, such as ecology, economy, livability and nature, and social, are the foundation for autonomic urban complex. The conclusion is, New millennium brought completely different understanding of urban planning as an occupation. It is not enough to suggest interesting planning solution anymore. Also, it is waiting for urban politics and management system of settlements planning development. The urban planning program is autonomic complex is extremely important for agriculture, ecological, economical, psychological, scientific, social, and technological models of our civilization development. To approach Barentsburg settlement to autonomous urban complex, the following problems should be solved as soon as possible. The introduction of solar and wind energy stations, modern logistic transport, Arctic-friendly storages, attractive positions for workplaces, local utilization of garbage, international education platform, wide range of northern leisure, and emergency medicine. Thank you for your attention.
Thank you very much. Have another professor share information for us? Okay. How time flies. I hope all of you have enjoyed yourselves today. Thank you everyone for taking part in our conference. And wish we will have such a kind of chance to express our ideas in another day.
Hello, everybody. Can you hear me?
Yes.
Hi. It's a pleasure to meet you on the conference. My name is Ilya, and I'm representing the Tepofol company. We're one of the major companies in Russia which are implemented in production of foamed polythene. And here is I want to make a pitch about an insulation system for Arctic objects. The implementation of insulation systems is primarily aimed at solving a problem of saving energy for heating rooms in cold period and protecting against excess heat in hot period. The second, no less important factor is the formation of comfortable indoor conditions, acoustic conditions, and favorable temperatures and humidity conditions in premises. The general picture of heat loss through plate insulation along the surface of the wall can be reflected using thermal imaging. Here are the properties of polythene foam are present on this slide. As you can see, the average density, the thermal insulation based on foamed polythene is designed for use in the temperatures range from -60 to +90 Celsius, water absorption by volume, vapor, thermal conductivity, and etc. The heat saving and efficiency of the insulation shell depends both on the low thermal conductivity of the thermal insulation material used and on the nature of the fit of the individual insulation elements, as well as on the stability over time of the thermal characteristics of the material and insulating structure as a whole. So reasonable minimization of the number and thickness of joints both between products included in the insulating shell and between products and structures is prerequisite for the thermal efficiency of the insulating shell. Here, as you can see how the sheets of foamed polythenes are sticked together and using the screws and heating fan. The heat saving and efficiency. The study of the experience of using products made of polythene foam led to creation of a new line of air layer material, as you can see on the right slide. These are heat insulating multi-layer materials containing flat layers of foamed polythene, polypropylene or rubber, interconnected with seams to form air layer between the layers. Layers can be made with or without a heat reflecting layer. Such a system has lower thermal conductivity compared to layered material, and insulating shells have better thermal performance. Tests to determine the tensile strengths of samples of foamed polythene is in the longitudinal directions on the solid product at the joints of product on the welded seam. Polythene foam is elastic material resistant to the effects of temperature, humidity, aggressive component contained in the air, which determines its high operational resistance. Considering the mechanical fastening of the foam sheets on the support structure and possible movements of the structure due to seasonal factors of base displacement. The experiment, including studies aimed at assessing the tensile strengths in the longitudinal direction. The tensile strength in the longitudinal directions is 82-92 kPa, and the strength of the weld is 29-32 kPa. Polythene foam with an average density of 18 to 20 kg per meter cube has a thermal conductivity of 0.32 to 0.034. The material practically does not change its properties under conditions of prolonged alternating temperatures changes from -60 to +90 degrees Celsius. Here you can see the insulations. There are the pictures insulations with the rolled polythene facade of the brick buildings, corners of the building's finished insulation shell, layered brickwork, layout of materials in the layered masonry, type of masonry from the side of the load-bearing wall view from the side of exterior cladding. including of a frame type house. General view and windows are open. Here you can see on the pictures. Roof insulation with polythene foam. So you also look at the pictures with a cold attic, warm attic for cottages with walls made with ceramic stones and cellular concrete blocks. Attic insulation. Here is how the insulation is applied. Cold preservation experience formation of insulation systems for the Arctic. Covering the ice stadiums, frameless constructions, the devices of installations coatings of the ice arena, frameless constructions. It turned out to be commercially justified, such an original at first glance decision at the preservation of snow in the off-seasons from spring to autumn, in order to use it as soon as possible in ski resorts or to form snow reserves to ensure compensated deficit in a case of insufficient natural precipitation in winter on ski slopes of any type. Foamed polythene rolls are prepared and placed on the insulating surface. The rolls are connected by a lock connection in accordance with the technology. It will be this stage, this is especially development technology was applied to so-called thermal blanket. Foamed polythene rolls are prepared and placed on the insulating surface. The rolls are connected by lock connections in accordance with the technology. It was at this stage that a special development technology was applied, the so-called thermal blanket technology. The concept of the pile house insulation system. As you can see, there is interior wall cladding, floating floor systems. The structural formation of the temperature field in an isolated structure above the ventilated space between the support columns. Visualization of the temperature field for Yakutsk called the temperature is minus 52, and visualization of the temperature on the right of the Norilsk city, and it's also called in the minus 46 Celsius. The structure of the formation of the temperature field in an isolated structure of a ventilated space. This is a Moscow region, temperature minus 28, construction between support columns, visualization of the temperature field. And this is the graphical interpretation on the right of the temperature distribution. This is the structure of the formation of the temperature field in isolated above the ventilated space constructions. And it's, as you can see, plus 20, minus 25. Temperature field visualization and the graphical field interpretation. The structure of the formation of the temperature field and isolation of ventilated space constructions. This is on the without insulation over ventilated space and with insulation. Here is the difference. Protection of the base of the building, the permafrost soil. When implementing this system, the soil along the perimeter of the building with the strip, the width of which is 1.5 meters, is removed on the depth of 0.5 meters. Rolled polythene foam with a reflective coating on top is placed in a pit with a slope of 3 to 7%, and if necessary is welded at the joints. Next, the pit is filled with soil. In this system, polythene foam firstly performs the function of cutting off soil and rainwater formed near the main building, and secondly is a heat barrier that prevents the penetration of external heat to the frozen ground. Conclusion. Insulation materials based on foamed polythene are environmentally safe, easy to operate and install, and have high operational resistance. The use of industrial waste and recycled polythene changes the properties of the material slightly. The developed nomogram makes it possible to determine the optimum consumption of secondary polythene considering technological factors, and can be used in the development of methodology for selecting the composition of modified polythene foam using secondary polythene. In critical operating conditions, the shortcoming of structures and materials hardly noticeable when used in a mild climate. manifest themselves to a greater extent. Firstly, it is the possibility of filtering cold air through leaks in the structures and insulation shells. And secondly, the presence of cold bridges during the constructions and operating of buildings. Thank you for your attention.
Okay, some another professors to share information for us. Okay, thank you all for coming to our conference. Today we have a lot of information to share with you all. And I hope all of you have enjoyed yourself today. Thank you everyone for taking part in our conference. And I wish we will have such a kind of chance to explore our ideas again. Thank you.